Hello, everyone, and welcome to the first ever live stream on Big Discussions 76 Science and Technology. My name is Dr. Anwar Youssef Dunbar. First of all, please like this stream, please share it, and please subscribe. When I last checked, my channel was knocking on the door of 400 subs. I was 2 away. So please hit the subscribe button. So this is the first ever live stream on this channel. It won't be the last, and I have a very special guest who's going to join me. And then we're going to talk about our subject matter, and then eventually we're going to open it up, and hopefully some other folks will come through, and we'll have a good time, and we'll learn something, and we'll have a fun time while learning something. So that was that song I was playing was just that was Vest Pocket by Foreplay. And I was thinking about what to play to get myself warmed up here. And that album was titled 4. And as I was thinking about this, I was thinking there's 4 of us eggheads who are usually talking about this stuff behind the scenes. And those are BGS's eggheads. So as you can see, the avatar is a little different. That's not the gray beard. That's not the high value man. That's a joke. That's me in my research lab as a graduate student at the University of Michigan almost 20 years ago. So I was about 20, 26, 27 there, and that's me at my workbench. And as you could see in the background, that's my desk, and there's stuff all over the place. And I was in charge of overexpressing protein in our lab. So that's me as a graduate student on the way to becoming Dr. Dunbar. I'm going to say a few words, and I'm going to invite Nicole up. So a short history of this channel. I started this channel because I wanted to, well, I'm a writer, I'm a scientist, I'm a regulatory scientist. We're going to talk a little bit about that tonight as it relates to the coronavirus and vaccines and stuff. But I'm also a writer, and I wanted to create a space to, talk about science. And I'm also passionate about getting those like myself or from my background involved in the STEMs. So I wanted to create a space where I could talk about science, careers, and also just talk science with other like-minded people. And I didn't intend for this channel to become the coronavirus channel when I first started it, but it just so happened when I launched it in February, that's when COVID-19 really blew our country over. So it just so happened to create a lot of content for me to discuss here. In terms of how me and Nicole, who's going to be joining me shortly, how we linked up, that was through BGS. I think as COVID started, hey, Herb's here as well. As COVID started, I started looking for content to create here on this channel. And I was just looking for articles, and my smartphone was getting articles, and I saw an interesting article on proposing that the virus came from nature. And then BGS, who I started, developing a relationship with, said, okay, well, I know someone else who thinks it's man-made. So we kind of met that way through BGS, and then Nicole came on my channel. There's a 2-part video. I split it in half months ago, where she educated all of us on what CRISPR is. So that will probably come up in the course of our discussion tonight. So I want to thank everyone for being here. And once again, please subscribe. And as the night goes on, I'm going to throw my Cash App in case you want to donate. You're not under any pressure to donate. But I just upgraded my StreamYard to accommodate 10 people. So I suspect there'll be a crowd coming through tonight. So in case you want to donate as the night goes on, I'll throw my Cash App and my PayPal in the chat in case anyone wants to drop something in the collection plate, as Minister Japp says. So tonight we're going to talk about the coronavirus and COVID-19. That's kind of the hot topic now. I've discussed it here a lot, and Nicole's discussed it over on her channel. And I thought it would be cool for us to join forces again in this live format where we could talk about it and toss the ball back and forth, and then have other people come up. So that's what we're going to do. So I'm going to just run over some points here, then I'm going to bring Nicole in, and then we're just going to we're just going to hit the ground running. So I'm going to start with the masks and aerosolized particles and droplets. There was an article this week on, I saw an article this week on CNN saying that the CDC had acknowledged that the virus could be passed on could be transmitted through aerosolized particles. And that's the whole reason we're wearing the masks, because there's a discipline called inhalation toxicology. I have some training in inhalation toxicology. And what you're looking at there is toxicity through inhalation. So as humans, we can go without water. I like to think of it as we can go without water for a certain amount of time. We can even go without food for a certain amount of time, but we can't go without oxygen for, longer than a matter of minutes before there's irreversible damage. So there's a scientific discipline called inhalation toxicology, which just looks at inhalation of toxicants, but also medications through the respiratory tract. And so one way you can be exposed to a toxicant or a medication, or in this case, a contagion, is through inhalation. And so the overarching hypothesis is that the virus is transmitted through aerosolized particles. And I think there was a controversy because the CDC put it up and then they took it down. But I think that the consensus is that that's how it's transmitted. So I'm going to quickly run through what I've covered here on my channel as it relates to the coronavirus. I have a background in pharmacology and toxicology, which basically deal with what molecules do in living systems, going down to the cellular and the molecular level, down to the DNA, the cofactors, the proteins, the enzymes, going all the way up to the whole organism. So that's my background. I have a research background. I'm in regulatory right now. And so I've been looking at this thing from that perspective. So I'm going to see if I can do the screen share here. This is my first time doing this. Okay. And it's not doing it. I think I'm gonna have to bring Nicole up right now to walk me through this. Nicole, I'm gonna bring you up. Bring you up a little early.
How are you doing?
Lioness, welcome.
Thank you for having me here. Good evening to you. How are you doing?
Thank you for coming. I'm good. I'm good. I'm good.
Yeah, you need some help with the screen share.
Yeah.
You just go down to share screen, click that, and then click share screen again, the blue bar.
Okay.
See, it'll say, do you want to share your entire screen, application window, or just stay in Chrome with the Chrome tab?
Okay.
I usually click application window and I have different windows open. It's unlimited number of windows. So if you pull down a tab or a different window, then you can click on that, and that way your whole screen won't be shared,
Okay, so I am looking at, oh, there it is. It's staring me right in the face. Okay. So I'll do this. Okay. Screen sharing tips. 2 monitors.
Yeah, you have to do that the first time.
Okay.
I think because I've done it before. It'll say screen sharing is easiest with 2 monitors, but you don't have to. You can just click share screen because it'll know if you don't have 2 monitors. And then I just go to application window. Sometimes I have to share the entire screen because I don't have more than one window open. And like if I click on application window and I just share, it's gonna it's putting another I think it put another window there for me. But anyway, I'll just stop and it'll go away because I'm not the host. But you'd have to click on that window to allow me to do it. But it's just that simple. Like if you have, you know how you have your tabs going across the top of Chrome? If you just click on whatever tab you want to open, you just click on that tab and just pull it down. It'll be separated.
Let me ask you this. What if I have a bunch of pictures in a PowerPoint? Can I show that?
Yeah, the PowerPoint, I have my PowerPoint set up as an application window right now. So if you click on your PowerPoint, just open it and then minimize it. It automatically captures that as an application window. And when you go to share your screen, try to share your screen again, it'll have that PowerPoint sitting there waiting.
Okay, let me click on the blue here and see what happens. Okay, so there's us, application window. Oh, there. Okay. Okay, so let me click this. Oh, can you all see it? Yep, everyone can see it.
Yeah, it's
Okay.
there.
So, Nicole, it's a good thing you're here. Okay, so I'm going to walk through, tell a little story here, and then I'm going to hand the ball off to Nicole, or we'll just toss it back and forth, and we'll just go from there. Okay, so this thing right here, this thing kind of rocked our world starting in February. Everything, people were getting sick. Went on lockdown. If you're fortunate to work remotely, you started working remotely from home. And I was fortunate to be in that group. So I covered a bunch of pharmaceuticals on my channel. And I'm going to run through those. And then I guess we can come back to what exactly this thing does and how it does what it does and how it makes people sick. So I'm going to click this like this. Boom. That is chloroquine. And I first became interested in that because this was in the news. The president said that a derivative of this one, which is actually, these are actually malaria drugs. So these are older drugs. This is hydroxychloroquine. You can see that it has the hydroxyl group right there on the structure. And it was thought that this had some efficacy in terms of treating people who were infected with COVID-19. And then there was a whole controversy surrounding it, just like everything surrounding the president. And then it kind of went away. And the question remained, is this a viable treatment? And so apparently there were some doctors who came to the United States and said that, from Africa, and said that this medication, along with zinc, is effective for treating it. And this was the less toxic form. And then I stumbled upon this glucose 6-phosphate dehydrogenase story. And so it turns out that there are people in the world who are deficient in the enzyme glucose 6-phosphate dehydrogenase. And it just so happens that people of African descent are expressed as polymorphism. So there are some of us who are of African descent who are deficient in this enzyme glucose 6-phosphate dehydrogenase. And there is a glucose 6-phosphate dehydrogenase deficiency foundation. When I get done talking, I'm going to drop that link in the chat in case anyone wants to go there. Again, I stumbled upon this by accident because this is a part of the story. Part of the concern was, are individuals who are deficient in this enzyme at risk for hemolytic anemia if treated with hydroxychloroquine? And also they're also looking at now, are individuals who are deficient in this enzyme, are they more at risk for COVID-19? And someone from this group shared a paper with me. When I get done talking, I'll drop that in the chat in case anyone wants to read it. And so they're looking at that right now. This is Remdesivir. This is an antiviral. I saw this in the news around March, April, and it didn't really go into my radar until Nicole mentioned it when she was schooling me on CRISPR. So this is an antiviral medication. This is a different strategy for treating people with COVID. This will actually, this is under trials right now. Gilead owns it, and this is a strategy for treating, for preventing the virus from replicating. This one, hydroxychloroquine, there was a paper, I created a video on this that showed that this one inhibited viral multiplicity, and it also alter the co-localization of the virus in the primate cells that they tested. This big guy, this is aviptidil. Aviptidil is actually a vasoactive intestinal polypeptide. So a couple of videos ago, I re-uploaded and remastered my pharmacology and toxicology series. I have one more to go. But in that first video, I made the distinction between small molecules and large molecules. And that's basically designated by the molecular weight of the molecule. So this, as you can see, is a very, very large molecule. And this is one that would be given through injection. Because it's too large, it's probably too large to make it across, to get absorbed by the GI tract. But also, since it's a polypeptide, it would probably be cleaved up by proteases as it made its way through your GI tract. So it wouldn't make it to its site of action. But this strategy is for decreasing inflammation. And we know that one of the what's the word I'm looking for, Nicole? Symptoms. One of the symptoms that individuals who get infected with COVID-19 is inflammation, and they go through this respiratory distress. Well, if you treat with something like this, you will depress the immune system and cause it to relax, and so that will make it easier for individuals to breathe, because we know that individuals who have been infected with this thing, once they go through this respiratory distress, they have to get on ventilators and go through the intubation and those kinds of things. And this, I'm almost done, is dexamethasone. This is a steroid. You could tell by its structure. This is a cholesterol derivative. And this also is a strategy for decreasing inflammation. And we know that in terms of pharmacology, that's just understood that that's one thing that steroids do, is that they decrease inflammation. So, but what's interesting is that all of those medications those are strategies for treating COVID-19 after the individual has gotten infected with it. But right now, we don't have anything to prime the body to protect itself against that. This is vitamin D. These were talked about, as well as proactive ways to protect your body and strengthen your immune system against the virus. Vitamin D and vitamin C. That's vitamin C. And I had a busy morning in anticipation of this, and I just created 2 videos talking about vaccines, because listening to your content, you had discussed this quite a bit, the fact that it would be a while before we would get a vaccine. And so I kind of did some digging, and it turns out that, so if you didn't watch those videos, I'm sure Nicole will talk about this. Once you find something that works, there's a much longer process afterwards before you actually have a vaccine that you can give to the general population. And even once so you have to find something that works. So what you're doing when you create a vaccine is you're basically presenting the body with an example of what it needs to fight off. We typically call that an antigen. One strategy they want to use right now is to introduce an mRNA. And I know Nicole has specific opinions about that. But you're basically exposing the body to something, and you're priming it, and you're readying it to fight this thing off. But once you have something that works, you have to go through all the trials, all the clinical trials, and to test for safety and efficacy, and to see if there are adverse reactions to it. And then even once you prove that, the companies have to set up the capacity to manufacture, to mass produce the thing. And then it has to go through the regulatory process. It has to go through regulatory affairs at the FDA. And there's a whole process through which the vaccine has to go through regulatory. And so, but with this one, they're trying to fast track it, obviously, so we can get back to our quote unquote, our normal. And there are also dangers to rushing it out there too fast. So I'm going to wrap up by saying that this could take as long as, this could take as long as 10 years, but they're trying to get lucky and get it done in about 2. Because right now, according to the New York Times article that I cited in that video, we still don't have a vaccine for HIV. So with that, those are all my talking points. Lioness, I'm gonna hand the ball off to you a little bit, and we'll go from there. So I'm gonna close this, and then we're gonna
stop sharing at the bottom. Okay.
Stop sharing. Okay.
That was good. So I appreciate you having me. Good evening to everyone again. Y'all get the like button up, because I know y'all wouldn't hit the like button. Get it up, hit it. So I want to piggyback a little bit about what you just said. You are right. There is no vaccine for the HIV virus. I'm anticipating that if they develop a virus that is not just feasible, but has a high efficacy for preventing the infection, in many populations, especially populations with comorbidities and pre-existing conditions, then they will probably be able to reverse engineer that and use some of those components of this vaccine for HIV. That's what I anticipate. Because it will be new, but it will be something that they can use on such a devastating virus. HIV is also a retrovirus. So to me, as a scientist, just looking at it, black and white on paper, it would make sense. If you can't use the exact vaccine, at least use something that's similar. Do everything you have to do to figure out the efficacy, the long-term effects, and you start small, small studies, mice, maybe rats, and go from there. I didn't know what else. I put some links in there in the chat. I was trying to put links in there in the chat about of things that you've talked about as far as the vaccines, things that you put out today, and also the way that you're talking about the drugs and the administration, the development of the drugs, and then the administration of those drugs. So I was just putting some links in there. There was one link I was trying to put in there pertaining to clinicaltrials.gov. I don't know if it got in there or not. Okay, there it is. I see it. So clinicaltrials.gov, there is a vaccine that they're working on, and it is an mRNA vaccine. Let me see if I can share my screen. Let's see here.
I'm going to ask.
Same thing. Oh, here it is. I got it. So I'm going to share my screen.
Is there anything I need to do for you to do that?
I think you just need to click on the other window, because I see the other window popped up with my name on it.
Add the screen.
So you just add that screen.
Oh.
All right. And then I'll go to that, make it a little bigger. So this came out September 3rd, and the title is COVID-19 and mRNA Vaccines, First Large Test for a New Approach. So what they're doing is, in this article, talking about the mRNA 1273 vaccine, which I mentioned in one of my videos. This is specifically for SARS-CoV-2. It is a messenger RNA candidate, and they developed it together in collaboration with a biotechnology company, Moderna, and the NIAID, National Institute of Allergy and Infectious Diseases. So July 27th, it was becoming more and more popular, and they were really encouraging this to be pushed forward. They have the mRNA 1273 as well as BNT 162B2 from BioNTech and Pfizer. So they're basically competing back and forth to determine who was going to get it out first. It's still in progress as far as I know. When I go look at clinical trials, they're recruiting. The reason why I was bringing up this study is because the groups that they had for the study, they have several groups for testing, and it seems like it's going to be a vaccine study where they look at the concentration dependence of this mRNA injection. So it was very good that you mentioned in one of your videos about some of these things cannot be given orally. You have to inject it. It has to be intravenous in administration because you're using mRNA. For us, when we do mRNA injections, it is tail vein injection. That's still IV injection for a mouse. It's equivalent to injecting you in your arm, right? So we do those, and nothing like a vaccine. It's simply just introducing mRNA that's foreign and seeing what happens. The problem that they were talking about it here that they will face is IP, getting the intellectual property secured. And if you notice, it's mRNA 1273. So it's not by itself. There have been many, many iterations of this particular vaccine that have been tried, and they also want to go and use it on patients that are various ages. So they may have some ethical issues moving forward, but nonetheless, it seems to be a good candidate for not only COVID-19 as a vaccine, but for future vaccines where mRNA is the primary vector for, getting that into your system. So
Okay.
they talk about some of the sections. I want to say one quickly. They're saying the proof is in the pudding. They've done a lot of the background research. They've looked at Ebola. They looked at other things. They're answering the question, why are they doing mRNA? Why is this important? And they talk about the immune system. Very important to read that. And then what I just mentioned earlier is what they're talking about here, moving beyond COVID-19. What other applications can they use for with this particular vaccine and other diseases? So that I thought it was important to show that and to talk about it from my perspective. I'm not a virologist, but I'm definitely not a virologist, not a pharmacologist or toxicologist, but I understand the basics of the principles of using these methods because we use very similar methods for our experiments. So hopefully you all can glean something from that, and don't be afraid to mix and match between what you see there. Listen to what an expert like Dr. Dunbar is telling you, and see like, okay, does this make sense? And think for yourself, like, does this really make sense to me? To me, it actually does make sense what they laid out. Would I take it today? No. They're not ready.
Okay. And Nicole, I need some more game here. Shop Talk asked me to make you a mod, so you could drop the links in the chat as well.
Okay, so if you have the live chat open, then you should be able to click the, let's see. If you have the live chat open on your phone, because on the computer, it's probably not going to do it. I don't think it will do it. You can try on your computer. You click the little dots next to the person's name, next to their comment, and there should be a something that drops down under those three dots.
Yeah, but I don't like see.
Make a mod, like that.
I don't see right here.
Okay, I'll try on your phone. If you go to the live chat on your phone and make sure it says live chat and not top chat, but it says live chat, click on my face, and then a drop down box with a lot of different options will come down. Try that then.
Okay, so I'm going into StreamYard on my phone then.
No, YouTube. Go to YouTube on your phone. Go to your YouTube video on your phone.
Okay, learning on the fly here.
No, it's okay. Because there are people that come in my chat and I communicate with them, off of here and in different places and on their channels. And I'm like, oh, I forgot to mod them. Because I don't feel like dealing with the studio. I just don't.
Okay. So
Click on the person's name or their face. Click on their icon, and then a drop-down box will come up.
Oh, add moderator. Okay, I'm going to do it right now.
Click add moderator. Mm-hmm.
Nicole Ali is now a moderator. All right. Build the plane as we fly it.
Something in the chat.
There we go.
Just to confirm. Okay.
So
thank you. Why am I still not going through?
What?
Okay. I was like, why is it not going through? I'm going to sit here.
Okay.
Thank you very much.
All right. I'm going to drop the link for the G6PD organization in case anyone wants to check that out for themselves. So that's there. And Nicole, so I have a question for you.
Yes.
What in terms of an mRNA virus, is that just a matter of injecting a solution of mRNA into someone's bloodstream? Because I imagine the mRNA would get cleaved up pretty quickly, right?
Not necessarily, because it's not naked RNA like you would just isolate from a cell or anything like that. Sometimes they use like a liposomal what is it called? It's like a fat or lipid based carrier molecule that helps carry it through, because it would get chopped up. It would get identified immediately as foreign molecule. But if it's going in, it needs to be protected, But the other thing is with the COVID-19, this is the reason why they're really going to have to make sure that people are tested and the tests are working properly. And I said this before, because this is a bloodborne virus. If you inject someone with the mRNA vaccine, it's going into the blood with the virus that's there. If you don't already know this person has infection because they have no symptoms, that's a problem. If you're giving them this mRNA vaccine, the reason why they want to use the mRNA vaccine is because it's molecularly attenuated instead of heat or chemical attenuation. So an mRNA vaccine is like a chop up, like it's the sequence is chopped up, so it's molecularly attenuated instead of the old school way where you heat it, or heat and activate, pressure and activate, something like that. But yeah, it's something that I forget the name of it, but there's something they use as a preservative for this type of vaccine. But yeah, I think it is actually better because you're targeting an RNA vaccine, you're targeting RNA virus with an mRNA vaccine. I think you mentioned once before as well that the tests out here, oh my God, the tests were they were trash. I'm just gonna be honest, because we had so many false negative tests. It was like everyone was negative. And we started to realize that the threshold of the test was too high. So, if the threshold is going to be, 50 microgram per mil or microgram per microliter, and you come in and you have 12 microgram per microliter, it's never going to see you. You'll be negative every time you come in, even if you fluctuate, 10, up, if you go up to 10, like if you go from 15 microgram per microliter to 25 microgram per microliter, that's still half. It cannot see that. So many of the tests, they were what they wanted to do. And also the way they took the test was an issue. If you're using cheek swab, you're taking saliva, you're taking nasal swabs, things like that, you cannot save that because it's degrading, right? It's the sample would degrade over time. The quality of the sample goes down significantly by hour after hour after hour. So you can't retest that, is what I'm trying to say.
Right.
You can't take the samples and Dr. Dunbar came in, he had a negative test. He tested at 15 micrograms per microliter. Our threshold is 50 micrograms per microliter, but I'm the person testing you. I don't know that. I'm just testing you because this is what I'm told to use. You come back 2 days later and you're like, what's going on? I feel horrible. And I'm like, okay, you were 15 micrograms, but it said you didn't have anything. And you're like, well, what's going on? I'm worse. You say, well, let me try to retest this. Forget it. You're not going to be able to do it. Even if you came in again, those 2 days later, and I tested you again, it says 25 micrograms per microliter. Well, guess what? I'll say, yeah, you have symptoms, but it may not be COVID because you're negative again. That was the main issue. So for me, yes, the vaccines are necessary. Looking into the future, yes, they will be absolutely necessary and possibly mandatory. However, the testing is still going to be an issue, whether the vaccines are out there and they're great and they're doing what they're supposed to do or not. You still need to have testing done, because people are coming from different places during this time, after this time, and I think the tests are so beneficial when you're dealing with elective surgeries that will come back online, meaning that people will start doing elective surgeries again. The testing is absolutely necessary. You can have a vaccine, to prevent that, but if you got an after infection, how effective is that vaccine?
Mm-hmm.
A lot of questions that you have to ask, and a lot of things that you have to read. Reference you to Dr. Dunbar's video on reading, and how important that is, right? In this time, I think everybody has a little bit of scientist in them now after this season of COVID, which is good.
Okay. Well, with that whole reading thing, I was thinking the other day, I'm doing a little bit of tornado chasing because you and BGS were talking about that. And I was like, you know what? I got to go back to getting that message out there. Let's see. I'm going to show something on the screen again that someone from the G6PD Foundation sent to me. So I'm going to try to screen share again. So screen share.
Mm-hmm.
Share screen. And let's see. Application window. Where is it? Opinion, how long? Okay, let me try that again. I want this one. Screen share. Application window, Chrome tab.
Mm-hmm.
Okay. Let's see. It's this one, I believe. Can you all see that? Yeah. So this is the paper. This is a paper that was recently shared with me. G6PD deficiency and severity of COVID-19 pneumonia and acute respiratory distress syndrome, tip of the iceberg. So they want to know if this polymorphism leaves the individuals at higher risk for COVID-19. And it states throughout the paper that individuals of African descent can have this polymorphism. Let's see. We hypothesized that G6PD, the most common X-linked enzyme deficiency associated with redox.
Mm-hmm.
I just saw it. Okay, the high mortality in African Americans and males in general raises concern for a possible X-linked mediated process that could affect viral pathogenesis in the immune system. So they're looking at this right now. I just wanted to skip down to some of the data. This isn't a robust report, but this is looking at patient data, and so they had it looks like all of these were African Americans. No, they were five African Americans with normal G6PD, 4 who were deficient in G6PD, and then they had 5 Caucasians. And so this isn't a very robust data set, but some of the findings were interesting. So for the normal G6PD individuals, let's look at hemoglobin. Okay, so for the deficient, you had a slight decrease in the hemoglobin, and as you would expect for the hematocrit, so that's the particulate portion of the blood, there was a decrease there as well. So this suggests that there is something happening with this deficiency. And then you also see, where is it? Where's the partial pressure of oxygen? They did show the partial pressure of oxygen. I don't see it right now. Here it is, this right here. So for the individuals who are normal, they have a higher partial pressure of oxygen. So that's basically measuring the patient's capacity to carry oxygen. And so I just wanted to show this real quick. I'm going to drop this.
What is that? Okay, so it says, I can barely see that. Can you make it a little bit bigger? Oh my God. I thought I was going blind. Woo.
So this is all individuals who are deficient.
P-values. I'm sorry. I just, okay. So this is saying that your GP, so this enzyme.
So here's the difference in enzyme. Yeah.
Is lower with this mutation.
Right.
Your ability to carry oxygen is lower with this mutation. So that could be contributing to people perhaps that if infected with COVID, then if they have this mutation, they wouldn't have the blood clots and things like that, because their body already is not able to carry oxygen as efficiently as somebody who is normal.
Right.
And what type of, do you know what type of mutation it is? I was interested in knowing that.
So you're there's a decreased production of NADPH, which impacts the amount of glutathione, and glutathione is an endogenous antioxidant. So people, the symptoms for this is increased hemolytic anemia, which makes sense because you're getting a decreased hematocrit right here.
Right.
So you're getting lysis of the cells, and likewise, you're getting a decrease in the partial pressure of oxygen in the blood.
Right.
So this is a preliminary report. I'm going to drop this in the link. Let me go back to.
But the mutation itself, like that was something that I was interested, because there are different mutations that would contribute to a patient having this. I mean, this is a significant change. It's a significant difference between GSPD mutants and normal. That is significant. Now, the ones on the bottom, they look janky, but the ones at the top, I don't trust D, E, and F at all. I don't like the p-value. I don't like the spread of the data. You know, it looks a mess. But at the top, A, B, and C, now that is critically relevant in my opinion, because of the spread of the data. And what I mean by the spread of the data is you can see how clustered the data points are in that sample set, versus D, E, and F. They're spread out. You have outliers all over the place. So it's more believable because it could be reproducible. But my question is,
That's an excellent point.
Yeah, I'm very critical of people's data. This is our lab meetings. We are like, that's some crap. Take that down. Well, you're not showing that. Go do that again, and we have to do it 10 more times before it looks like something. Start over from scratch every single time, just to get the right. What is it really saying to us? If it still comes out that way, okay, that's fine. But at least you have to try. And they have the G6PD mutation. You have point mutations, you have splice variant mutations, you have single nucleotide polymorphisms, you have the frame shift mutations, deletions, insertions, nonsense or missense mutations. So that's why I was wondering if, like, what type of, do you have that? And maybe it's in their paper, I don't know. If you search the word mutation, maybe it will come up.
Okay.
Because I was trying, when I was looking it up, I was like, oh my gosh, this is so much stuff. Oh, okay, never mind. 200. All right. It says 200, over 200 mutations. Okay. Mm.
Okay. Yeah, this is
Wow.
all still pretty new. So.
Okay, it'll come from that reference number 8 then. Probably, yeah, 7, 8, and 9. It'll come from those 3 references, the type of mutations. That's what okay. When you put the link in the chat, I'll have to check that out because this is very interesting. And for me personally, my work, because it's involving 2 things that I like. One is ROS, and 2 is mutations. ROS, for one reason I like it. ROS is reactive oxygen species, and for my studies, reactive oxygen species are important because usually, like Dr. Dunbar just showed, mutations are sometimes helping you to resist ROS, or help it. Unfortunately, the patient succumbs to ROS when they have these mutations. And another thing about ROS is we are noticing it is contributing to biological aging. That's something that we're looking at. Chronological aging is not as significant, to us because it doesn't really mean anything. Like yeah, everybody has their birthdays, and you're a year older and things like that. But chronological aging that's a societal, thing that people do. Your biological aging is more important in terms of how we're going to treat you, how we can prevent certain things. And ROS is one of those things that really, with other genes such as hypoxia inducible factor 1 alpha, beta, some of the TGF beta family genes, and there's a couple of other ones that are out there. Well, actually, a few of them out there that are contributing to ROS. And there's one enzyme that would prevent or reverse ROS is SOD, superoxide dismutase.
Mm-hmm.
So we look at those and we try to see in sequencing how the patients are expressing these genes. And if they have high levels of these genes, they have high rates of biological aging. Biological aging usually is like your organs are aging. A 30-year-old man has the organs of a 50-year-old man, for instance. So you celebrating being 30, but you have the organs of a 50-year-old. That's not good. And so a lot of the work that's being done now, at least with regenerative medicine and even cancer research, diabetes research, is on reversing these patterns before the cells get locked into, going to ROS. Because ROS is used to destroy.
Yeah.
Or clear out, right?
Well, I think another piece to that, and this is something my graduate advisor was very interested in, and every time I go up to Ann Arbor, we talk about this. But also, there's something with molecular chaperones.
Mm-hmm.
And the last time I was there, he was telling me that so proteins have their own unique conformations, and when the chaperones break down or stop doing what they're doing, the hydrophobic clefts become exposed.
Right.
And that he was telling me that has something to do with the aging process as well. I don't know if it's an offshoot of the increase in the reactive oxygen species you were just talking about, but I know that he was telling me that that's been implicated in the aging a process as well in certain disease states.
Yes.
Yeah.
Yeah, that is very true. Like their aging is something that people look at, and we're writing so much on a biological aging components. DNA damage is one thing that occurs where DNA damage is one of the precursors for cancer. One of that's like, it's not a rate limiting step, but it is a precursor for cancer. DNA damage also is unfortunately a precursor or an identifying marker for aging. Men who, if you get old enough, you're going to develop some form of benign prostatic hyperplasia, or an early stage of lesion is cancer, prostate cancer. If you're a woman, you get old enough, you're going to develop ductal lesions, ductal issues in the breast, ovarian issues, cervical issues. So it is due to aging. So reversing those steps that the cells take to get to cancer, to get to tumors, before they are locked in to those genetic profiles, we want to stop that. So that's why we have to study from the top down, like study everything. For me, we're not only looking at the prostate, we're finding out, what's going on in the liver. What are these patients? What are their diets? Do they have metabolic syndrome? And we're looking at the liver to see if, the liver ages as well, as a kind of like a sponge or filter for your body. It ages over time. And men who have prostate cancer have older livers biologically. They're older. And so we are really trying to figure that out. One thing we're doing is going back to the mRNA injections. Going to the mRNA injections, find out which genes are embryonically expressed and start injecting those into the mice, and putting cells into surgically into the liver of these mice, and see if that new mRNA that's there or new peptides that are there can help retrain these cells what they were supposed to be doing. And it is working, but the lethality is the issue. We're trying to, fix that, because a lot of the cells that we're using, I think we're using too many cells, but anyway.
Okay. And Nicole, I want to go back and ask you a question about the mRNA,
Yes.
an mRNA vaccine. So in terms of mutations, we know that antibodies, when they're generated to read certain epitopes or certain regions of the antigen, right? And so if that virus mutates, then even if you create a vaccine for one form, it won't necessarily recognize the mutated form, right?
Yes, it will. Because I was just, okay, so the link that I tried to put in there earlier, I'll try to put in there again. But the link that I was talking about, they were saying that mRNA vaccines are very effective because they simultaneously can target multiple antigens and pathogens. And so there's a broad spectrum utility for using mRNA vaccines. You can use them for a range of diseases, whether there's mutation or not. So it depends on how this mRNA vaccine is developed. It goes back to development. There are many reasons why you want to use mRNA vaccine versus some of the other vaccines. As I said earlier, you're doing a molecular attenuation. You can also add multiple mRNAs within that one injection instead of giving multiple injections. So for me, personally, that is good because it cuts down on the frequency of vaccinations. It cuts down on the statistics that you have to do for all of this because it's a one-shot deal. And it also alleviates the burden that healthcare workers have. So all of what I'm saying is in the actual article. Some of the other things they mentioned were even if you have this mutation, it would not matter, because if you have something like COVID-19, and let's say you have 100 different viral bodies in your different types of viral bodies in your groups in your body, right? 100 different flavors, I should say. And this mRNA vaccine knocks down 90 out of 100. Your treatment regimen is going to be it's going to be cut down a lot, where they don't have to do as much with you, because more than likely it's going to hit a lot of mutations. So that's the idea. I mean, even if you have 5, okay, if you have 5, but the mRNA 1273 vaccine is primed to hit up to 100 and something, then you're good. You're covered. for a long time, because your body, your immune system is going, your adaptive immune system is going to take that. And remember, you've only had 5 different groups, 5 different flavors of vaccine in here, mutations, right, in here, and they're all gone. If anything else pops its head up, how many other, combinations of mutation can really come if you've already been vaccinated? So I think it is good. It's something that they've been working on for a long time. My only issue is that they need to get to patients early, with the tests done, because coming in and making sure that the patients don't already have the flu. I'll end it right there.
Okay. Now, I noticed. Well, Linus, first of all, thank you for the Cash App, and thank you to Artisan Mike as well for the Cash App. I noticed you left that comment under one of my videos earlier in terms of early. Now, when you say early, can you elaborate on that? Are you talking about immediately after they get infected, or within a week, within 2 weeks? What are you referring to?
Early would be, because right now it's hard to tell. Like early is, I would say within a week. If you go, it seems like longer than a week. Some people it's like 3 or 4 days. So it's hard to tell, but in general, I think within a week, because you have to think about the average immune system response time. It's 3 to 5 days. So, 7 days, like after that, it's you're, depending on the mutation you have, the mutation of the virus that you've been infected with, it could be downhill from there. So getting them early, and people actually, my thing is, I would hope that people are demanding the test to be more, to be better, to have better quality testing. People are out here demanding for not to wear a mask, but you need to really be demanding that the tests that you need to take to determine if you are okay or not, because you're like, I'm good, I don't have no symptoms. No, that's stupid. Sorry, but that's horrible to think that way. You need to go in and make sure that you're okay. I've gone so many times and I'm like, you need to test me. I need to be tested. I need to be tested. I need to test. They're like, are you okay? I'm literally like almost at the verge of like, just act like I'm sick. Like start coughing, and just take my mask off and just act a fool. I'm almost at that point. Like I'm really like, I need to test. I need to know. I'm around children, and I'm around a lot of stuff. So I really need to know, but that's one thing I would say, like getting them early, and people paying attention to people around them that are sick, that they live with, and recognizing that just because I don't have symptoms, my mother's living with me, for instance, my son's living with me, he's sick, he has it, I don't have symptoms, I need to make sure I don't have it too. Just being responsible.
Okay. We're coming up on an hour here. So after listening to some of your content, you've been very outspoken with your subs that it's going to be realistically a vaccine it's going to be another little while. And in the New York Times article that I taped a video on earlier, it said that, we still don't have one for HIV, but also they've been able to come up with medications in the meantime to kind of offset the fact that we don't have. You don't want to contract HIV, but
right.
There are almost 2 races going on right now, one for a vaccine and one for medications that will manage the thing. But I saw something interesting. In that New York Times article that I read, which is that there is a danger to getting a vaccine out there too early. So you can get it out there too early, to the point where you can make people sick if you don't identify all the issues early.
Yes. If you don't identify what your population, this is why Dr. Fauci was saying, early on, Dr. Birx, Dr. Fauci, Dr. Redfield said what he said, but then he flip-flopped. But anyway, moving on. People said different things, and one thing that remained true, even with us who are mere scientists, lowly scientists in the lab, we were saying, because we analyze what's been happening, we are able to analyze it, and we're saying, like I just said earlier, you have to have the right test. Like, it's just, I don't know what else to say, and on top of that, you cannot rush science. If you want to rush it, then we will give you something rushed and you won't like the outcome. You will not. And you will wonder why no scientists are taking this. Oh, why aren't the scientists taking this? Why aren't they going and getting the vaccine? Because we ain't stupid. We're not dumb. We know how this process works. I personally know how the FDA process works. It's very slow and expensive. Very, very slow. Oh my gosh, they're so slow and it's very expensive. And for this type of task, this is a monumental task. We have never seen this virus ever on this planet in this, in this infectious way that we're seeing this virus, this pathogen. And I wish that people would be more patient and allow the process to occur. Like I said the other day on our New Styles channel, a lot of the people that are recruiting, that are administrating the clinical trials, they cannot get off the ground and turn that recruitment button off the clinical trials website because their patients keep dying. So the numbers keep going down. They need enough patients to run a trial. You can't implement what you plan for the trial if your sample number, which is the N, is not high enough. I can't run a trial with 10 people for this type of thing because the ends don't justify the means. I'm spending this much money, or I'm sponsored by this company with this much money for, maybe $12 million, and I'm going to spend $12 million on four patients. I can't even get statistics out of that. You need these trials have dozens or even hundreds of patients at a time. I just hope that people are, recognizing that this is a process. It may seem messy, but it is a process. Please listen to people that actually do the work every day. They're on TV. Well, they were on TV for a while saying this, and you're absolutely right. Dr. Fauci was there during HIV, during that emergence, right?
Mm-hmm.
And now, it's funny. My mom was like, he's like saying the same things, like pretty much that they said then, but just, as far as like safety and concerns and limitations of what they have, what they can do. And I was like, wow. And she said, I was telling her things before he was saying it. Like, I was telling her things a week or so before that she would hear on TV. It's fine. I don't have an issue with that. But as far as the vaccines, coming out, people thinking that they're coming out this year, I can't.
And Nicole, I want to read something real quick from that New York Times article, and this was back a few months ago. But let's see. It says it's here that, and I'll leave this in the chat. It's here that talk of fast tracking the timeline meets the messiness of real life. What if a promising vaccine actually makes it easier to catch the virus or makes the disease worse after someone's infected? That's been the case for a few HIV drugs and vaccines for dengue fever because of a process called vaccine-induced enhancement, in which the body reacts unexpectedly and makes the disease more dangerous.
Right.
Okay.
Yeah. And see, that was something I was thinking as far as from your expertise, as far as toxicology, because that's something that that's why you have so many different vaccines being tested at one time. So many things being tested at one time to see what works. And that one trial I mentioned, it's a lot of them. I put the link in the chat where they're using mRNA-based vaccines they have several concentrations. They go from a low dose all the way up to a high dose concentration. The one I looked at that I did the video on, I think it was like 6 different concentrations, you know, 6 different groups. And they were placebo matched for each group, which is good because they were meaning that they had a placebo group for concentration 0. They had which is just the vehicle, whatever the drug is in. Maybe it's in saline, so they give you a saline injection. And the placebo, which is something totally different. Then they have the control. Placebo is the control. Then they'll have like 10 milligram injection, or dose, right? Micromolar dose or something. So they give you that concentration. Then they have 20, then they have 25, then they have 50, then they have 100, then they have 150, then they have 2, they go up. And for each concentration or each dose that they give, they have a matched control group for each dose. So when you do the bar graph or the histogram with the statistics or the box plot or whatever they do, there'll be 2 boxes per group. They'll be matched to each other. And they also did it by age, which is very good because age is a comorbidity with coronavirus, as we know. Okay. There are others that are doing it based on I think it was a BMI, and some were doing it based on blood pressure, like all kinds of things that they're doing. But yeah, that toxicity that could happen, it's a confounding variable that they try to mitigate before putting this out on the market, which is why I'm like, why are people so impatient about this? It just let them work, man.
Well, I know for the University of Michigan, we want to fill our football stadium back up with 100,000 people.
Oh, wow. We have a new stadium down the road, and every day, Jason's sitting here with his jersey on, with his hat on, watching the games. Every day they have games. I'm like, oh my God. And he was watching so many reruns that I'm thinking it's a rerun. It's live. I was like, they're at the stadium? He said, yeah, the new stadium. I can't go. But yeah, that's true. Human nature. Yeah.
Yeah, we want what we want. Nicole, I'm going to read one more thing, and then I'm going to ask you one more question, and then I'm going to drop the link in the chat so other folks can come up and participate. So this is also from that article. It says, while some steps in the vaccine timeline can be fast-tracked or skipped entirely, approvals aren't one of them. So this is talking about regulatory affairs and what the FDA has to do. There are horror stories from the past where vaccines were not properly tested. In the 1950s, for example, a poorly produced batch of a polio vaccine was approved in a few hours. It contained a version of the virus that wasn't quite dead. So patients who got it actually contracted polio. Several children died.
Yes.
So there are dangers to going too fast.
Yeah, destroy the severe neuropathy children. I mean, that's your brain, your spinal cord, everything. Just severe issues. As polio is affecting, the nerves, affecting the muscles, skeletal system, everything. And I mean, there's a lady my age. She had a polio vaccine with my mom, and to this day, she can't walk very well.
Mm-hmm.
Her walking she was not like that before the vaccine. That's a medical injury. She was not like that before the vaccine. She got the vaccine, and it very quickly. So yeah, that type of medical injury you want to avoid. This country is not in a position economically, politically, socially, anything. ALLY, anything Ali. We are not in any position to rush anything like that. Can you imagine the implications of malpractice, medical malpractice,
Yeah.
on children, babies, pregnant women, elderly people, working class adults. And see, that was polio, and that was when the technology was not as advanced, obviously, as it is now. There's no excuse because of the technology we have. There's no excuse not to do the right thing. You have the time. We have the time to do that. If people would do what they were told to do months ago, it simply put a piece of fabric over your face, over your mouth and your nose and your nose. I must say,
Yep.
I'm pointing up to the ceiling like an usher in church because you don't know how many the kids. I'm like, your nose, and like cover your nose too. And they're like, I can't breathe. Breathe slower then, take your time. But if they just did that type of stuff, it would be so much, so helpful, not to the system, to you. You have to be here, later for your children. You have to be here at the end of the day. I mean, if they rush those vaccines just for a stupid election, and that's what it is, because comparing that to your life right now and what we're dealing with, that's like inconsequential at this moment with what we have going on. Presidents come and go, and I understand that Trump and Biden, all that stuff. I get that, but at the time, like right now with this, we never had a virus like this in human, like I said, human history. And I'm looking like, okay, you have all these mutations. What if you develop a vaccine, it doesn't cover certain mutations? It has a 30% coverage. Then the person gets reinfected. They recover, they get reinfected. And the vaccine they took in between when they were recovering, it doesn't cover these new infections they get because it's a new mutation. Then they get the flu. And now they're gone because they had the flu and COVID at the same time. But it's a lot of things that people really need to think about. I would say, like I always say, start with reading, start with asking questions and reading these things. Like as you're reading, ask the question, why did they say that? Why did they write that? And really start going through y'all are missing out. Like you really need to start watching. Dr. Dunbar has a lot of good information on his channel. And I'm like laughing because a lot of stuff you put, it is what I do from day to day. Yep. And I appreciate you. I appreciate your channel.
I appreciate you too, Lioness. So I think I said this on my channel before, for people not in the science community, in this instance, what we're going through right now, viruses obviously can be contagions. But I'm looking at my graduate school picture there. Viruses, as we discussed regarding CRISPR, viruses are also research tools. And in my research lab as a graduate student, we were interested in a specific protein, and I was responsible for over-infecting our insect cells with our baculovirus to mass produce our protein. So these are also research tools in a lab. And so that leads me into, well, before I get to the question, everyone, if you're new here, please click the like. I think when this started, I was at 398. So I'm knocking on the door of 400. And after I ask Nicole this question, I'm going to drop the link in the chat in case anyone wants to come up. And I'm going to drop my Cash App there as well in case anyone wants to make a donation. But going back to the viruses also being research tools, can you briefly go over for us again the whole piece about it being man-made? I mean, now we have someone from China coming out and saying, yes, we did it.
If you can share my screen, I will definitely.
Yeah, but that's how we met, was that this whole discussion about it. Can you talk a little bit about that?
Yes, if you can allow me to share my screen, I have.
Sure. So yes,
I think you have to click. So I made some slides. I typed a lot of notes, but notes are kind of boring and everything. So I wanted to make some slides. Just a few, dozen. Just a few to, just elaborate on what I'm talking about. So if we come down to the newest information about SARS-2-NCoV-19, aka COVID-19. I have had a timeline and everything. So there are several studies. The issue with these studies conducted from 2020 is that they're in bioRxiv, and that is not a peer-reviewed site. However, a lot of the research there, those authors do have research that is in like Nature Medicine, for instance, here. And then you have reprints of different things. So there are more from 2020 and even more from 2020. Let me make this bigger so you can see that. Okay. So this is how I felt, because I just feel like I'm going too far with everybody, and everybody, this is how y'all feel at the end of my videos when I'm done doing it, or when I'm done doing a stream about it, or, Dr. Dunbar, I'm like, this is how everybody's going to feel. Oh my God, I can't do it. I can't take it. This is the main one. This is like me. This is too much. When I first started learning about this, literally, I'm overwhelmed. So please don't be overwhelmed. It's okay if you are a little bit. Just take a breath. Do whatever it is you do to relax, and trust me, it'll be okay. I promise it'll be all right. All right. So SARS-2 or COVID-19 is a sequence that is totally different from previous coronaviruses or COVs. And this is just giving the reference genome sequence. So what I do in my laboratory as far as viruses is using CRISPR-Cas9 or CRISPR-Cas13a to as a vector to cut out certain gene sequences or to put gene sequences in. My specialty is cutting gene sequences out, because usually those are genes that are helping to promote cancer growth, and I don't want that, so I cut them out completely. And the cell is therefore unable to make that gene and unable to make that protein for that function. So that function that they would have used to make bigger tumors is completely gone at that point. So this is giving an open reading frame. This is for SARS-2, single-stranded RNA. It is giving the open reading frame 1AB and open reading frame 1A. And you can see there are a lot of different mutations that occur. Anytime you see these cuts that are happening like this, these little pieces, there are a lot of mutations occurring from the 5', 3' end of this sequence compared to SARS, the first SARS that we saw. So I went through this paper before. This was conducted this year, where a SARS-CoV-2 infection model in mice demonstrated protection in neutralizing antibodies. So that was that's the reprieve, that's the relief you all get with this study, at least, where they actually found that neutralizing antibodies were helpful in protecting the mice from this infection while they had this infection. So neutralizing antibodies, mRNA vaccines, these are options. Neutralizing antibodies, of course, as a treatment, and mRNA vaccine as prevention and prophylactic. So here is just a graphical abstract of what they did. They took the adenovirus, which is the DNA strand sequence that they used. That adenovirus is human ACE2 receptor. They did an intranasal inoculation of the mice. 5 days later, they gave them SARS-CoV-2. So they have human ACE2 sequence with SARS-CoV-2 infection. It goes straight to the lungs and many other organs. Then they were able to take that, get the antibodies from it, inject those antibodies into another mouse, and then block any infection. So because they produce neutralizing antibodies against COVID. So that was a good study that I talked about in detail. These are just examples of what is being done in the laboratory, right now to knock down the pathogenicity of this particular virus, and as well to study the antibodies that are produced after that infection. The antigens are also important to study. And earlier in my slides, I think it's like slide 15 or something, I was talking about a lot of the antigens they studied. They've already studied the antigens for SARS, the first SARS. And so right now, during this pandemic, because it is a pandemic that we are in, they're studying the antibodies produced more than the antigens. Don't think they're not studying the antigens. They are. It's just that the antibodies seem to be more popular and more critical for developing therapy. So I'll stop right there. If there's, because I don't want to go on any further. If there's any questions,
Okay.
anything like that.
Okay. Yeah. So you said a lot.
Sorry.
I thought I heard you before kind of list off some of the benchmarks of a man-made virus.
Yeah. So, oh my bad, I'm going the wrong direction. Let's see. Coming on down. Yeah. So there are certain benchmarks that are certain things that are, you would say from this study, that are saying that there may be in vitro manipulation. There are 3 lines of evidence that they say support their contention that this may be laboratory manipulation, and that could be what has helped to produce this SARS-CoV-2. One is the genomic sequence of SARS-CoV-2 is very similar. I noticed that. It is suspiciously, as they say, suspiciously similar to that of a bat coronavirus discovered by military laboratories in the 3rd Military Medical University, Chongqing, China, and the Research Institute for Medicine in Nanjing, Command Nanjing, China. That was number 1, that the sequences are very similar. I went through that a little bit at the end of one of my videos. But the second thing that's even more important is something they've been studying since like 1999, 2000, which is receptor binding motifs, or even receptor binding domains, known as RBMs or RBMs. So RBMs within the site.
Hey, Herb, can you mute? I just need you to sign. Hey, Herb, can you mute your mic?
Just the individual who has the room. I need the name, the number, and the time is 7:22.
You are, if you press. Oh, I was saying you should be able to mute him if you need to. He's probably not ready to talk. I thought that was you playing music or something.
No. I want to hear what you're saying.
You with the music. No, but the receptor binding motifs, to me, I was very surprised that this even showed up in the paper, because I'm literally studying RBMs right now. I just thought that was crazy. RBM 20 and RBM 38, RBM 15, RBM S1. So yeah, I'm studying a lot of them. And this was really, really weird, because they said that the spike protein of SARS-CoV-2, it determines the host specificity of the virus, like how you can recognize the virus that looks just like the one from the 2003 epidemic. In a very suspicious manner. Now, people will say, well, viruses, that virus in 2003 went all around the world, different places. Yeah, but when the sequence is so similar, but with very, very strange mutations, and RBM mutations, it seemed like it had been manipulated genetically. The third thing is that SARS-CoV-2 contains a unique furin cleavage site in its spike protein, which is known to greatly enhance viral infectivity and cell tropism. So what that means is, I know you're like, oh my God, what the heck? What that means is inside of the little buckyball, which is the structure, the physical structure of the virus, is a little ball with a bunch of little, horns and spikes sticking out of it. Inside, the inside layer of that ball, of that virus, is where you have these furin cleavage sites of the spike protein. So, those spikes go inside the ball. There's an inner layer, and then there's the outer surface, which is where the spike comes out. So there's a mutation that has occurred on the inner layer of that ball of the virus, the coronavirus. And they said that this cleavage site is completely absent in this particular class of coronaviruses found in nature. There is no cleavage site. So what is it called? The crystallography, the protein crystallography of a protein, where you see these nice, beautiful crystalline structures of proteins. They have certain dips and gaps and different things on the protein, and those gaps and dips and different spikes and things that are sticking out, that is where something else would bind. But the natural coronavirus in the bats don't have those same cuts and dips. And, you know, if you hold your hand up and you open your fingers, you see all the dips in between your fingers, right?
Mm-hmm.
Imagine your hand as a protein. And if you open your hand and hold up the number 5, the dips in between your fingers, those are cleavage sites, for instance, where something else can bind. If you close your fingers and leave your thumb sticking out, that's what the coronavirus, basically what they're saying. That's what the natural coronavirus looks like.
Mm-hmm.
If you open your hand, your fingers, that's what SARS-2 looks like. Totally different.
Okay.
Why do you have all these cleavage sites and you're supposed to be natural? It makes no sense. Only reason you need cleavage sites like that is if you are highly pathogenic, because you're a better virus at that point. You know, and it doesn't take much of you to do your job, but you do it extremely well, right? And so they say, in addition, rare codons associated with this additional sequence suggest strong possibility that cleavage site is not the product of natural evolution, because it takes a long time to evolve these different sites. So it could have been inserted into the SARS-CoV-2 genome artificially by techniques other than simple serial passage or multi-strain recombination events inside co-infected tissue cultures or animals. That's the issue. That's the main issue. And then they show sequence with these different mutations, and they go through, there's a lot of sequence homology. This is too much for you all. It's too much for me too. So I pulled out these parts here. I know it's a lot. This is all the sequence pulled down for all these different bat coronaviruses in SARS-2. And then you blow it up, you see that look at all these gaps. I mean, it's like, why do you have all these gaps here? And then you look at the one where it's filled in, and it doesn't make sense. The gaps, what they were saying is that the original or natural bat coronavirus sequence is lacking some specificity for human because it's for bats. It's lacking some of the functionality that would be required to jump from human to human to human. But the one that we have now, it has all this blue. Blue is mutation, all of that.
Okay.
Just down here with the green part here, higher, you see the numbers going up, higher in the strand, 500s, mid 500s here. Then you don't see as many gaps. You don't see as much blue here, the top one. This is Wuhan, human. Wuhan, human, 1, bat, right?
Right.
You see all of this blue. That is not good, right? And see, the dashes don't mean there's nothing there. It means it changes. It's not the same as human. It can change. It can be a different sequence, but they don't have you can't just put all those sequences there. It would take up too much space, right? So they put dashes there. That peptide is specific for what? Bat. This is USA. What is that? 2019 novel coronavirus, USA. And this is the coding, AZ1. I don't know what AZ1 is, but this is USA. This is Wuhan. Look at the similarity all across. But bat, natural, different. That's not normal. You can't do that. That's not natural. That's what I'm saying. It's something wrong here. And this just goes through steps, but I'll end there. I'll stop right there.
Okay. Yeah, we have Black Uru and Herb up. But before anyone else says anything, what's interesting is that on one of those slides, it said military.
Let me go.
It said military something. And so when I was reading that, I was thinking, for those who don't know, the world militaries have whole science divisions, and our United States military has whole science divisions. So I'm not saying, that they're intentionally creating biological weapons, but I'm just saying that I noticed that on that slide.
Yeah, it says discovered. discovered by military laboratories in China, 2 military laboratories.
Yep.
So this does not mention Wuhan Institute of Virology, but these are military laboratories that are have subsidiary laboratories under them.
Mm-hmm.
So they didn't say it here, but if you have the sequence from Wuhan, then more than likely you're talking about the Wuhan Institute of Virology as well.
Mm-hmm.
So that's just my opinion. But
yep. So militaries aren't all bombs and ray guns, and
right.
They're doing some biological stuff as well.
But this is just my opinion. This is my interpretation of the data. My interpretation of the data, I could be wrong. I still stand there. I could be wrong.
So Black Uru and Herb, if you want to say something before you do, hey Nicole, I wanted to say it because I memorized it. So CRISPR, so clustered repeated interspaced palindromic repeats.
Yes.
I memorized it after.
Oh God.
I read it that first time.
Better than me. Oh Lord, that's good.
Herb, how's it going?
I'm sorry, Dr. Dunbar. I'm just at work, so I have my mic muted, so I was trying to step outside so I didn't have too much background noise. Just a couple questions. Actually, when you guys mentioned mRNA, are you speaking about messenger RNA?
Yes.
Okay, I just wanted to be sure. It's been a while since I've done anything related to science and biology, so I just wanted to be sure. Now, is there a specific viral load that one has to be exposed to in order to actually risk contracting COVID?
Is there a certain what? I didn't hear what you
viral load, or what? How much do you need to be exposed to actually contract it, or is it just a matter of being in proximity with somebody who's infected?
I don't know how much, but I wouldn't want to be. I wouldn't want to know, because if you have a certain mutation, it may not require you to have. You may not need as much to infect you and destroy certain organs. I don't, but I don't know what that concentration would be. Yeah.
Are you referring to the initial exposure?
Yes.
I think he's referring to what the initial exposure must be.
Yes.
Initial exposure.
Yeah. What quantity or whatever,
Yeah, I don't know.
however you would describe it scientifically, you would have to be initially exposed to for contraction.
Probably the viral titer.
Yeah. So the viral titer they have in mice is very low, but that's mice. I don't know what it is for humans. I think like nurses probably have a better idea, or physicians have a better idea, because I think it's changed somewhat, or I don't think it's a standard. That's what I'm trying to say. I don't think it's a standard for the virus based on mutation, based on patient health as well.
Okay.
Yeah, Super Triz. He's asking about the virulence virulence, however you pronounce it, of the virus. What would be the like average viral load of a patient coming in with the infection?
Look, the reason why I asked that question is because I've worked through COVID itself. I haven't had any time off, and I'm consistently with the public. So given we take safety precautions, I always really want to know, because between you guys and I have a brother who's working in DC in the military. He gives us updates on anything that might change.
Mm-hmm. That's good. That's really good. And he's right there in DC. I mean, getting the updates and everything, especially from someone in the military, that is a very valuable resource to have.
Okay.
Hey, Nicole, I have quite a few questions. They're not directly scientific related, but more sort of historical or more social science related.
Mm-hmm.
Do you know typically how long historically how long it has usually taken to get a vaccine, a safe and effective vaccine introduced into, into
the population?
Yeah.
I would say minimum is 2 years, because
now, that 2 years, what's the beginning of that 2 years?
The beginning of the 2 years is what they're doing now.
No, I'm saying how would you define the beginning of that 2 year? What would that 2 year, would it represent the initial identification of the virus? What would that be?
Yeah, that's what they, back in January, February, they were sequencing what they had. See, now it's easier. For the flu, you don't have to do this because it's Spanish flu that's mutated over and over. And most of the vaccine development is done in China. But for this is brand new. And so they were sequencing the viral RNA genome way back and determining, okay, what does it compare to? What mutations could it have? Is this likely to mutate? Yes. What kills it? What can we use to destroy it? When they came and told us that we will not be able to use UV, and that we have we knew that right then. They're like, you have to be careful because we can't use UV on this necessarily as easily as others. And I was like, this is RNA. This is not DNA. DNA is just gone with UV like that very easily. So those types of things, they began testing the employees, at least where I am, testing employees. They began doing studies on the mice, as I showed earlier with SARS-2, where you can recapitulate that infection in the mice. And then the solution was neutralizing antibodies for that particular study. Getting all the data together before recruiting the patients and knowing what they're going to test the patients with. All of that is happening. I don't think so. That's this year. And then next September, October, November, many of those trials hopefully will be done. So that's basically 2 years right there, because you're not going to get the final stages of regulation and testing done until later on next year, and you won't get distribution the first of 2021. That's not going to happen, or 2022. That won't happen. So, it would be in the spring of 2022. If they rush it, at least let's make sure they have the science. That's all, and everything done properly. That's all I ask. But within those 2 years, that's everything that they need to get done.
Hey, Black Uru, I want to show you guys something.
Yes.
This is from the New York Times article I based one of my earlier videos on. Just give me 1 second. I'm going to do the screen share again. Nicole taught me a new trick.
Just take your time.
Application window. Can you guys see that?
Yes.
Yeah.
Okay. So this is what a typical vaccine timeline would look like, and look, keeps changing. Okay. Stop. Okay, there. So you can see all those steps. You have the research, the preclinical, the phase 1, phase 2, phase 3, building factories, manufacturing, approval, distribution. And that's over a series of 14 years for this particular example. And I think this is what COVID normally would be, but they're trying to condense everything so that it looks like this.
Yes.
Yes. Right. I mean, how does the logistics work to get from 14 years to 2 years?
Well, because this is based on, I don't know what virus is based on, but I know when they had SARS, the first SARS, like that was like 10, it was like 10, 12 years. They were projecting out for different things for that. And the technology, like I had a timeline on the PowerPoint, the technology, if you just go through some of the, or there's tons of studies I added, but you can see the advancement in technology if you look through the methods of those studies and see how fast they can do some of these sequencing and the analysis, the biostats that's needed to do the analysis is very fast, like overnight, compared to a week to analyze 1,000 samples, they can do it in a day. So that condenses it down based on the development of new technology. And there are more people that are willing to do the work too, or people that are willing to volunteer for, or even get enumerated, get paid for the trials as well. There are more people that are available to do that in many instances.
Okay, so based on what you're saying, it does seem like 2 years is an actual legitimate time frame of getting it done.
Yeah, when I look through it's a time frame, like it's a time frame that I've seen on the clinical trials website. When I look at when they're supposed to be estimated completion date, when I look at that, and I'm like, okay, if you calculate back and then you count up when they're supposed to be finished, and then you go look at their peer-reviewed research that they've done before the clinical trial, and they talk about 2 to 3 years. Some say 2.5, some say 3.5, some say 3. But usually it's like 2 years, like when they're completely finished. Some say 3 because they want to have a year to do work up to the trial, and then 2 years to be through the trial all the way. That doesn't mean in 2 years you're going to be getting a vaccine. That means in 2 years they're done with their part of the process, because it's up to the process. So you can add on more time.
Yeah, I mean, obviously disseminating it throughout a country of almost 400 million people.
Right.
Yeah.
Right.
I have more questions, but I'll defer to some of the other people on the panel.
Well, thank you. Thank you for asking.
Super Trez, you want to add something?
Hey, what's going on, everybody? I think that the 2-year timeline is pretty accurate. We just have to bear in mind that it's also based on the mortality rate. If the mortality rate was higher, they would disseminate the vaccine a lot quicker. It's just a risk versus reward scenario. So there is a sense of urgency, but it would be a lot more urgent if the mortality rate is higher. I'm actually seeing just overall drop in the amount of cases that I get based on social distancing and mask wearing. I think a lot of the more susceptible in the population have already contracted and perhaps even to a certain extent succumbed to the virus. And so those that are remaining are those that are either just lucky or just practicing good social distancing and mask wearing and hand hygiene and things like that, other things that they can do to mitigate the spread of the virus. So, yeah, that's pretty much it.
Yeah, I'm always concerned. That was one thing we talked about, the healthcare workers, because Super Triz, you are a healthcare worker. And we were discussing mRNA vaccines earlier. And one of the things they mentioned was that not only would the mRNA vaccines be able to target many antigens and different pathogens, but it would reduce the burden on healthcare workers. So I was, I'm not like pushing that as like the absolute solution, but there are many different reasons why you see trials. And I put the link in the chat earlier, why you see a lot of trials with that. But yeah, you're right. People are taking this seriously. And I hope that they continue to take it seriously, even if the vaccine that they use is coming out and being administered. I hope people still continue to take it seriously.
Well, I guess the question then becomes is if, with the actual creation and dissemination of the vaccine, will it function like the flu vaccine? Will it be a seasonal vaccine? Will it be something that's disseminated year round? Will they have to change the actual composition of vaccine annually to reflect what strains they believe will be prevalent in a given population, which would be more of a guesstimation, educated guess, nonetheless. But there still be strains that wouldn't necessarily have an actual protection against, just like every flu season. They estimate, they give like maybe, between, I guess, 4 to 5 different strains that they imagine will be present. Yeah. And then they make the vaccine, formulate the vaccine based on that. And then sometimes you have a rogue strain for which they didn't anticipate. And those people who are exposed to that particular pathogen potentially could get infected. So I guess that's the question moving forward. What should we expect with this vaccine, COVID-19?
What should we expect? Yeah, see, as far as it being seasonal or giving throughout the year, that's a question that I have too, now that I think about it. Oh, is that
a function of how regularly it mutates or what?
That's a function on the actual increase in prevalence of the actual virus. We see we see the influenza transmission rate increase exponentially, at this time of year. October to mid-February is the flu season, so that's where we see the rise in cases. And so that would be the ideal time to actually disseminate the vaccine, because throughout the year there's flu still present throughout the year, but throughout the year it's mutating. And so they look at the actual, the mutations. They have a trajectory upon which they base the strains that they'll formulate the vaccine for. And so then they actually disseminate it around that time when they have the most cases. So, I mean, technically, you can technically get the flu vaccine year round, but it just makes the most sense for it to be seasonal based on the transmission rates of the flu. But what we're seeing here in the COVID is that there is an annual transmission, but who knows? Maybe it will increase, at certain times of the year. It's so new that we don't have all the data yet.
Yeah, we don't know. I hope that it does decrease, because that's one thing I mentioned was to be careful, because you're going into, we weren't going into the flu season at the time, but I was saying, it's coming. And you don't want to, like, my greatest fear was like people who had COVID, who recovered and then get the flu. And then you can be reinfected with COVID, so to have COVID and the flu at the same time, like that was like a fear of mine. I was like, wow, but what if you have the flu vaccine and then get COVID? Like that, I was like, my head was just spinning with those thoughts. But yeah, I mean, going forward, what do you think, Dr. Dunbar, as far as going forward with the vaccine, like as far as the steps to get there?
Well, I think that, obviously they have to find something that works, something that's showing efficacy. And, I work in regulatory affairs. So you have to ensure the human safety next.
Yeah.
Because people are already suspicious and skeptical of it, right? I mean, there's fear that they're putting some kind of chip in there. Of course, I don't know how they would do that. I don't know if technology has gotten that small yet, but and there's just a genuine distrust of what any vaccine would be at this point in some of the population. But I think, yeah, you got to make sure it works, and then you have to ensure that the safety.
Well, yeah, there's a genuine distrust of the science, but we can go back to what you mentioned earlier with the polio vaccine. Many people, they haven't forgotten that, and many other instances. So, but I think for this, you're right. We have to look at the data. There's no excuse at this point because of the technology we have, how fast things can be analyzed. Right now, the issue, a lot of the trials it's not analyzing the data, because a lot of them are still recruiting. If you go on the clinical trials website, the issue is like they're not having issues with analyzing and figuring out if this is a good concentration for this vaccine or not. They're trying to get people there. A lot of the patients are dying, or they're not healthy enough to participate in the trials, based on their standards they've set in the trial. Your exclusivity standards may say you're not healthy. You can't, you have these symptoms. You can't be part of this trial. So that's slowing down the process a lot. And I think that's why I'm glad that you're focusing on the treatment options as well on the other side.
Has there been any discussion revolved around the ethics of such a trial? Because obviously, to test the efficacy of a vaccine, you have to actually expose people to the virus, and so I guess that becomes an ethics concern, because obviously, individuals. Well, I won't make an assumption, but I don't know if this actual trial has a financial component, if they're paying participants, and if so, then you will look at which populations would be attracted to a trial with the financial disbursement. It would probably be your more vulnerable or or disenfranchised populations, and then that further complicates the ethical component of this particular study. And then for those individuals who do participate in the study, is there a mortality rate associated with participants? Because if you have exposure to the actual virus, and you've had you have a vaccine, right? You're testing the vaccine. Individuals who get the placebo are being exposed to the virus with absolutely no protection whatsoever. And now you have to face the actual treatment component. And even individuals who we treated who are by all intents and purposes appear to be healthy, some of them have long-standing ailments associated with their infection, if they even survive. Now, I believe that from my experience, and this is all anecdotal, I see most people who are relatively healthy do recover from the COVID. But from a long-term standpoint, I don't have all the data whether or not they have, long-standing afflictions, but I know that some people do. So I guess that's the ethical component in the question that I have.
The ethical, okay, I'm writing them down because you're right. Because as you're speaking, I'm looking on here.
Hey,
a lot of these are phase 3 that I'm looking at, phase 3 trials. But looking at the ethical component, that's then they don't even list it on the trial website. So the only thing they have is for this particular trial is you have to contact Moderna TX, which is the sponsor of this mRNA 1273 trial. And they give their number and everything, and they have an email and all that stuff. But yeah, you're right. I'm writing it down.
Hey, Super Triz, I have a question for you. But I want to acknowledge my brother, Amal Dunbar, is there in the chat, and I want to acknowledge the master teacher. I see you there in the chat as well. Super Triz, so you're in the clinic?
No, I'm in the hospital. I'm
in the hospital. Is there anything in particular that any trends that you're seeing in terms of age, or is there a particular form of the sickness that you're seeing? Is it the respiratory distress, or?
Well, I mean, first and foremost, obviously, it's the same trend with any transmissible disease. When you have an aggregation of individuals, particularly individuals with compromised health and immune systems, for instance, a nursing home, you have a higher rate of transmission in those areas. So the actual trends that I see reflect that. A lot of nursing home patients come in, and then also people who have pre-existing health conditions, generally people who are unhealthy, generally don't fare as well. They have those that do recover have a longer recovery process because it's complicated by other health issues such as diabetes. A lot of times with the COVID, I see concurrent infections. So most people who have COVID, actually, I would say probably 99% of the patients that I take care of, they're on antibiotics as well as treatment, Remdesivir treatments for the COVID, because they have concurrent infections.
Wow.
And at the clinical presentation, obviously, is more akin to pneumonia. So you have pneumonia. When we think of pneumonia, we think of there's viral and bacterial pneumonia, but oftentimes in pneumonia, the associated symptom is the inflammation of the lung, particularly of a particular lobe. We see consolidations in X-rays, and that just means that there's an inflammatory response based on whatever pathogen has invaded the body. But with COVID, it's not necessarily relegated to one lobe. It's generally a more extensive inflammatory response. So you see an entire lung, sometimes both lungs, inflamed. And with that, you have the resultant fluid accumulation.
Yep.
And you have an impaired oxygen exchange at the alveolar level.
Yes.
And so those are the clinical presentations that make COVID, more problematic, is because it's a more extensive inflammatory response.
So you have to mitigate
does that answer your question?
Sorry. So Super Triz, you have to mitigate that's not an acute, that's more chronic lung infection, right? And so, or inflammation.
Actually, that's acute. Those are the acute, like the actual acute inflammatory response is
Okay.
the actual. So basically, what happens is that the alveolar, they kind of fill with fluid, and so that impairs the oxygen exchange, and so then there's just a cascade of sequelae of events that occur within the body, based on your inability to exchange oxygen and exchange carbon dioxide as well. Both of those processes are impaired, and then it just has a cascade of events.
So how do you mitigate that with the treatment? Because you can't increase the dose and potentially have like this contradiction with that drug increasing in concentration or dose with another drug that they're already on, like an antibiotic. Like how do you deal with that? You know what I mean? Like if you have this patient that's here, the fluid of the lungs, if you're going to give them remdesivir or some type of treatment, like do you just like slowly increase the doses, or how does that work?
Actually, you really can increase, and particularly like a lot of the antivirals, they have a lot of side effects when you start trying to increase the dosages. So a lot of times what you have to do is you have to just mitigate and manage the fluid. So you do that through a ventilator. There's different PEEP maneuvers where you actually increase the actual expiratory pressure within the lungs, that kind of slowly pushes out that fluid from the alveolar sacs and keeps the alveolar open. And it's basically also positioning the patient. We do what's called a prone maneuver, where we actually position the patient on their stomach, and that actually recruits different areas of the lung, and it causes shifts in fluid and things of that nature, which allows better oxygenation. So basically, it's more like supportive care and treatment. Just like with any virus, a lot of times we just basically support, that your body's own immune response to the presence of those pathogens, and your body's ability to phagocytize viruses and things like that, based on your antibody and immune response. But that's pretty much all we can do. Viral meningitis, a lot of viral infections is more supportive care, providing oxygenation, providing IV intravenous fluids, providing nutrition. If it's a long-standing infection, we'll go ahead and do the TPN and things like that. So that's basically all you can do, is kind of support. And generally speaking, people tend to recover, although there is people who don't. So
I have another question about the G6PD, because I know that that's a mutation that Dr. Dunbar is very interested in, and now I'm starting to get interested in more, because we were talking earlier about this mutation, and what you have is he said, correct me if I'm wrong, but a reduction in NADPH, increased hemolytic anemia.
Yes.
And with this mutation, with those patients, there were more than 200 mutations of this gene. So I'm thinking, if that is the case, maybe the patients that find it harder to fight this inflammation of the lungs, and this is doing blood flow as well. And as you said, Supertriz, exchange of CO2 and oxygen, things like that. So maybe these patients, maybe the C6PD needs to be looked at more seriously. Maybe.
Yeah, so it's the opinion of the G6PD Foundation that it's been neglected up to this point. So they're trying to bring more exposure to it. I'm going to leave the link for that in the chat right now for that foundation. Hey, Supertriz. Well, first of all, we're at 2 hours. If anyone's just coming in, please click the like. When I started the stream, I was at 398, and I want to join the 400 club. And if you want to make a donation, I'm going to leave my Cash App in the chat. Supertriz, are you the patients you're seeing? Are these in any particular age group, or is this across the board? Because one of the arguments was that it was elderly people with pre-existing conditions.
Well, again, just to preface my response, it's all anecdotal, based on my personal experience, obviously. and again, this is all for entertainment purposes only. I don't offer medical advice, but the trend that I see is honestly is more people, I would say 40 plus, and more concentration, or actually a higher prevalence as you increase in age, and that's just basically what I see. But I think those numbers could be skewed because of certain, like say for instance, like I mentioned, nursing homes. You have an aggregation of people, and viruses and any pathogen, bacteria, they tend to spread rather quickly in places like that. So that can kind of skew the numbers. But yeah, I do see more, but I have seen people young die. I've seen people young die in their 30s. And this is kind of off topic. I had a patient maybe like a couple months ago, died of the flu. It wasn't even flu season. Died of the flu. And he was 27 years old. So wow. I mean the misconception that, you know, that just because you're young is not something that you have to worry about. Not only is that irresponsible, but that's just plain wrong, because not only can you actually become infected and potentially have either, you know, long-standing health conditions, because we really don't know what are some of the long-term effects, particularly of, you know, organ damage, lung scarring, and things like that could affect your quality of life later on. But also the people around you. And we have actual responsibility as members of a society. You know, we share our environment with other people. So we have an actual obligation to be safe. So, I mean, that argument that, you know, I don't have to worry about it. Well, I mean, you're passing it. I mean, if maybe you contracted because you could be a carrier and not actually exhibit symptoms, or maybe you exhibit mild symptoms that you mistake for something else. And also like for instance, I'm gonna leave it at this. I had a patient, like this patient was sick. We didn't know why they were sick. Tested for COVID like 4 times. They were negative. And then the patient got so sick we had to intubate him. And so when we intubated him, we did a sputum culture, you know, from a bronchostomy. So it was deep within the lungs. And that specimen from deep within the lungs came back positive for COVID. So all the other the nasal swabs, and trust me, when I do my nasal swab, it goes all the way back. And those were all negative, four in a row negative. Wow. When we did a bronchoscopy, the patient was positive. So we have an obligation to be safe.
Mm-hmm. Mm-hmm. Wow. We were talking about that just earlier, Dr. Dunbar, like as far as the testing itself and like how invasive you just described that is something people would want to avoid. And also, yeah, you're right. People are being irresponsible because they're like, oh, well, it only hits old people, whatever. That's why you have these people, younger people here. Oh my goodness. In the Valley, down in Long Beach, they were just dropping because they're young and they're going to parties and going out and stuff. I was like, oh my God. But yeah, as far as okay, I had another question too. As far as the concentration or the threshold when you're looking at that broncho swab, that deep swab that you just described. So what is the threshold? Is there a threshold for like different ages or different like symptomology when they present? Like how is that determined? Is it just positive, negative, like colorimetric tests?
Well, so basically they say like our test now, when we look at the results, because now this is a different specialty. This is actually laboratory services, which is you know, microbiology. But right. When I actually look at the results, it says detected or not detected for SARS-CoV-19. So that's basically, so I'm and then now mind you, there's also an actual, they do like a DNA. Mm-hmm. Now it says DNA. I'm not sure if it's actually RNA, but on the actual
DNA is DNA because they reverse transcribe it.
Okay. Yeah, so they actually, so we have two different tests.
Mm-hmm.
And the DNA obviously takes a little bit longer, but
Right.
we have like the rapid test that we can get back like in 3 hours. And so I don't know what the actual threshold, or I think it's just actual presence. If there's a presence, even if it's, I don't know if they can detect one virus, but if there's a presence that they can detect, then they consider you to be COVID positive. And then we go and just the whole process is really daunting, because we have to isolate patients based on their symptomology even before we have confirmed results. And so now not only are we allocating resources to isolate a patient, but that patient is being isolated on a unit with people who have confirmed COVID. So they could be negative at admission, but then positive because of the exposure based on being on that unit.
Wow.
AB, do you want to jump in? I see you came up a little while ago. Or Black Uber?
Yeah, I think I have some questions for Nicole.
Go ahead.
Nicole, earlier you were reviewing the changes or the modifications that apparently were made to the virus, the artificial changes or whatever to the virus. Are you all able to specifically, like, I think you referenced the origin or the possible origin of the changes. Do you know when those changes occurred?
No, I would have to go back and look at that article. I don't know when.
Well, typically though, as a process, can you do an aging of changes? Would you be able to typically, as a procedure, determine when some gene sequencing, or resequencing occurred?
I know what you're saying, but I don't know how I would do that. Because a lot of the, that would be, if you had to, and you had all the data, yeah, you could go back and look at that when it was changed, because it would have probably been a protocol that somebody was using, and they have everything dated and cataloged. But me from the outside looking in, no, I don't have an idea, because I would think it would be like whenever they started in China reporting these strange infections that were flu-like, but more extreme symptoms. But I would think like more extreme, like very, very bad flu. Even some of my coworkers, they were talking about family members back home in China saying, there's this really bad flu, and I didn't hear about it until it was like this is almost Christmas. So, but it would have been like earlier, I think like early December, but that doesn't mean that the virus would have been changed like end of November, because it would, if it had spreading from one person, who knows, it could have been 2-3 weeks before you really started to recognize a pattern. So it could have been, way October, like I don't know. I'd just be guessing at that point.
The other question I have is, I'm assuming that this wasn't intentional, right?
I don't think no.
Well, I guess my question is, how often does incidents of sort of an accidental release of this sort occur, and how does it typically occur?
Of a virus like this, definitely not often. You have to be very irresponsible for something like this to, get on you from a vector animal, and then like it gets in your eye when you're not wearing proper PPE. Like I deal with viruses a lot, and I deal with viruses in animals, but they're small animals. I'm under a hood, like I'm behind a chemical hood with a sash. So
Oh wow.
I have gloves up to my elbows. I have, even though I'm behind a sash, this glass that's coming down this hood, I still have goggles on, you know. I have a bonnet on to cover my hair. I have booties on. I have a bunny suit on. I don't even have the lab coat. I have a bunny suit because of the viral reagents and the viral, cassettes that I'm using, the containers I'm using. There's virus in there. It's alive. And so, or active, I should say, not alive, but active. I cannot risk that, but the way we have, for me in my facility, the way it's set up, you have to purposefully walk it out the door.
Well,
There's so
yeah.
checks and balances there. And so that goes to like the security, the infrastructure that is in place, where if you accidentally spray yourself, okay, now it's because you didn't report that. Like I said before, I had accidental injection from, I'm trying to inject the animal, but I knew what I had. I knew what I was dealing with, and I just went to employee health, took care of everything, did what I had to do. But if you have a person who's just like, I don't care, it's like, it's not that big of a deal, they don't think it's that serious, then yes, you can have this happen. But it's just about me. It's really about being just extremely careful, like extra paranoid. It's not even careful. Like I'm paranoid when I'm in there. Everything has to be aseptic. It has to be clean. I don't reuse stuff, and that becomes very expensive. But I don't care. I just keep doing what I have to do.
It's understandable. I got a couple questions. I can't think of who it was, but somebody from CDC said that the best way to because you guys have already said that we're not looking at a real vaccine till maybe a couple of years down the road. You said the best way to combat this virus is to pretty much wear a mask everywhere you go. And I want to get you guys' thoughts on that.
Mm-hmm.
Well, in terms of transmission, I'm sorry.
Mm-hmm.
The hypothesis is that it's being transmitted through aerosolized droplets. And so what they're trying to gauge right now is how long, let's say I breathe out and there's a cloud left me breathing out, how long will that cloud remain in suspension in the air?
Okay.
So I'm saying that to say that yes, so that's the hypothesis about how it's being transmitted.
Right.
Okay.
So that's why you have to put a mask on.
And I think that one of the actual concepts is not only to prevent inhalation of viral particles, but also to prevent you expelling them. So if you have the virus and you have like a sneeze or a cough, the mask that you're wearing will help contain that virus and prevent it spreading from the general spreading to the general populace.
Right.
So now, bear in mind that not all masks are created equal. Not they're all viruses. I'm not sure what the actual measurement in microns the COVID-19 virus is. Maybe Nicole Ali knows that, but some certain. Excuse me.
I said I don't even know. More microns, so.
Yeah, but so with that being said, certain masks they have spaces in between the fibers, and with enough force and correct positioning, a virus, of a small enough size can actually bypass the mask from either direction, either outgoing or incoming. So, that's just something to think about as well. So that's why social distancing becomes important as well. So you have multiple layers of protection. There's actually three layers of protection just by mask alone and social distancing, because my mask, your mask, and the distance in between us.
Okay.
Approximately 0.06 to 1.4 microns. That's smaller than some of the materials that we use as far as our filters. Like our filters.
You're talking cell atom spawn?
That's referring to the mass median aerodynamic diameter.
Yeah, the micrometer.
Yeah.
So 1 times 10 to the negative 6 meters we just call it microns. So the 0.06 to 1.4 microns is the approximate size, because you could have viral particles or whatnot that would be smaller than 1.4. But a lot of the materials we use are 4 micron, 2 micron. The bigger ones are like 8 micron, where we're using cells. So this is a virus smaller than a cell. But N95, of course, the best ones that they're saying to use. Supertris is absolutely right. There are articles out there that say, all masks are not created equal in so many words. So please be careful with that too. But yeah, this virus is so different because the one thing that makes it, well, many things make it different, but the main thing for me is that you can be asymptomatic, but be full of virus, basically.
Oh, wow.
So wearing your mask, washing your hands, staying away, keeping your distance, absolutely important. I don't understand why it's so hard for people just to wear the mask.
Some Americans are hard-headed, and there's nothing we can do about it.
Well, I think the other thing is that we're in an era of a lot of misinformation. So there's so much, it's this or it's that or it's this or it's that. And
right.
Not everyone has uniformly believed that this thing is real.
Yeah.
Which is scary, but there's nothing we can do about it. It's like talking to a brick wall when you talk to some of them.
Right.
Because believe me, when I go out, I only go out to the store, and I always have a mask on. And well, here in Indiana, you can't really go in the stores without a mask on. They'll kick you out if you don't have a mask on.
Right. Anytime I go indoors to a store, or there are a couple of instances when I went to restaurants, but yeah, you have to wear your mask in.
Yeah, I don't even go to restaurants. I might order Grubhub, but I do all my cooking at home. I don't even go to the restaurants anymore. I'm trying my best to social distance.
Well, what's interesting, my primary care physician in July told me he's skeptical about going to restaurants, but he said you're relatively safe on an airplane. And I was like, really?
Really?
Yeah. Yeah, he said he said the hardest part. He said the hardest part is through the airport, but once you're on the plane, you're relatively safe.
Okay.
How does that work? How does that work?
Yeah, that's a great question.
Well, if you figure, if they take the middle seats out, you're with your mask on, I guess there's a very low probability that
musical chairs, okay,
that the respirable atmosphere you're generating is going to float over to someone else. That's what I gleaned from what he said. You're sitting in place, wearing a mask, so.
I'm wondering, amongst you all with the scientific background, and either as researchers or as medical professionals, there's all sorts of media and communication involving the status of this crisis. Are there any sources of media that you find to be particularly credible, that us lay people would be more inclined to encounter?
There's a channel BGS shared here, and I'm subscribed to it. I can't think of it off the top of my head right now.
Prosperity?
Yes, that's the one. I tend to trust what's said over there.
What was that again? Pardon me?
It's called Peak Prosperity. I'll try to find it.
Peak Prosperity.
Yeah. Yeah, I like it because well, I think that he is in the field, but I can see that a non-science person could understand a lot that they present over there.
Okay,
So
thank you.
no problem. I'll put the link in the chat too.
Anyone in the sort of the standard or traditional media that has had it more correct than others? I've heard Dr. Dunbar reference to certain um, NYT articles. I mean, have for the most part the New York Times has credibly reported on this issue, or is it sort of a
Yeah, that's a good question, Black Uru. I pulled that when I was looking for a specific topic. I would say check multiple sources and use a healthy sense of skepticism.
Mm-hmm.
But I would say check multiple sources and then take the consensus.
okay?
And talk to as many scientists and healthcare professionals as
Yeah.
possible.
Yeah, which is what I'm doing right now.
So it would help to know someone like Super Tris, who's
Yeah.
there, seeing
Okay.
and
I just have a quick question then. Back in about November, I had what I believe was just an ordinary flu, but it actually put me down for about 3 days, which for me is uncommon. Is there any way to actually test to see do they have any tests actually available to see if there's any antigens for COVID?
Mhm.
So your question is, see if there are antigens for COVID?
Yeah, antibodies.
Antibodies.
Yes.
Okay. Triz, do you know? Oh, I don't think
I'm not sure if the actual DNA test would be able to determine if you've actually had an exposure to it or not. I'm not exactly sure of the circumstances of that, because most people I encounter, they're not testing to see if they've had it; they're testing to see if they have it. Because they're actually
Yeah.
presently exhibiting symptoms. But just
Right.
like kind of like on a kind of a counterpoint, most people who say I've had flu and it wasn't that bad, they really haven't had the flu, because when you have the flu, it's debilitating. Like when you truly have the flu, like sometimes you have like flu-like symptoms and you feel a little sick, but I mean when you have the flu, you literally feel like you're gonna die.
Well, no, like I said, I was down for 3 days. I never call into work when I'm sick. I actually called in. I was 3 days. I was pretty bedridden.
Yeah, so what I'm saying is that like your previous experiences where you thought you might have had the flu, they probably weren't the flu.
Okay.
Like when you sound like you say you have to call out 3 days, that sounds like the flu. When you're bedridden, that's like the flu. Yeah, I've had the flu twice my whole life, and it was pretty bad.
Yeah. Same here.
I may have had it a couple of times, so I'm not sure. High fever and could barely move for like 2 or 3 days.
Yeah, I had to go to the hospital. Like, I'm done. I wasn't gonna. I couldn't even think straight. So, my I mean, dehydration. The bed was completely wet. Like, I was like, I can't do this. This is crazy. But as far as Herbert, you were asking about if you, what did you ask? Restate your question again, because I was missing some of it. Herbert, are you there?
Herb, you still there?
Herb,
You there?
Well, Herb,
You answered it.
Oh, okay.
Okay.
well, piggybacking off of Herb's question, I do recall months ago, I was watching a story with my mother on 60 Minutes. One of the New York hospitals, they were taking plasma from patients and giving it to other patients.
Yeah, convalescent.
Some were able to recover based upon being injected with the plasma from other patients, I think, who had already survived.
Yeah, I've done that a couple of times myself personally. I've had a couple pages where I've done, call it, as Nicole Ali said, convalescent plasma infusion. But
so when you only do that if the the source of the blood had the antibodies, or would you do that for some other purpose?
if you're injecting, if you're administering plasma for the sake of providing antibodies, then yes, there would have to be somebody who has had some type of exposure and recovered, if that's the purpose of the convalescent plasma.
Okay.
Yeah, because there could be other purposes for convalescent plasma, but yeah, for the purpose of antibodies, yeah, you would have to have exposure to a particular pathogen and and produce antibodies in response. So the purpose of the antibodies is just so that way, when the virus is actually introduced into your body, your body's able to recognize it, as a foreign substance, and actually attach the antibodies that signal to certain classifications of white blood cells to aggregate to that virus and attack it. Generally speaking, it's going to be some type of phagocytosis, which is just basically consuming the virus and metabolizing it.
So now, what is? I mean, and I think Nicole mentioned this earlier, that it's possible to become reinfected with the virus. Is that possible?
Well, there's like just for instance, like you can get, like I've had the flu twice.
So that is essentially goes back to the issue of if there's a different strain of the virus, if you get like a different strain, because when you have developed antibodies from the first infection.
Well, see, here's the thing though. The thing about it is that, like, depending on the virulence, even if you've been exposed to a particular pathogen, there could be enough pathogen, either just by the initial introduction or by replication once it's in your body, to overwhelm your immune system.
You mean a second time? A second time,
yes. So at that point, then you have to quote unquote fight the infection. Whether or not your body can fight it on its own, or whether or not you need some assistance. That a lot of times, like if you've already been exposed to, like if you get a secondary exposure to the same exact pathogen, your body has developed antibodies. It's able to recognize it quickly, formulate an actual response to it, and combat the pathogen before it replicates to a point where it completely overwhelms your immune system. So sometimes the subsequent infection is not as bad.
Okay.
You see what I'm saying?
Mm-hmm. Mm-hmm.
So like maybe the first time you might have required hospitalization. The second time, you take a day off from work and you're back good again. Who knows? It's all, of course, speculative, because again, we don't have the data to support or substantiate any claims that we make, at this point. But based on what we've seen in the past.
So Nicole, other than me sort of piquing my paranoid, evil scientist concerns here, what other possible reasons would they have resequenced this virus that might have been considered legitimate scientific purposes?
Well, Black Woman, I'll take a stab at that. Looks like she might have stepped away for.
Yeah, she may have stepped away.
But as I said earlier, these things are also research tools. The first time I interviewed Nicole, she was, she told me about CRISPR and gave a nice little discussion about what CRISPR is. But there are all kinds of uses for these things. In that picture, right there, when I was in graduate school, we used the virus to overexpress our protein of choice so we could study the hell out of it. So she's back now, but there are any number of uses for viruses, whether it's you're studying it to characterize infectious disease, or if you're using it for some other molecular biological method.
Mm-hmm.
Nicole, I think we were asked what would have been the purpose for creating something like this?
Yeah, for the manipulation of the genetic structure of the virus.
Well, that's I'll give you the abbreviated answer.
Okay, thanks.
I would
I'm
have.
not sure I can follow the unabbreviated version.
I mean, I'm saying there's a long answer and there's a short answer. Short answer, if it was me thinking ethically, I would have used it for the same way I use the ones I use now for treatment, for prevention, for diagnostic, prognostic methods. I don't think personally that was the intended use for this based on the virulence that we're seeing now.
Yeah.
It's just, but I could be wrong. Hey, what do I know?
Well, I mean, obviously we're speculating. I just asked, just kind of being a non-scientist, I'm trying to visualize the methodology that kind of goes into, why these changes would be made, and then how, of course, could have been accidentally released into, there are a sequence of coincidences there that when you do the statistics on it, it seems fairly thin, but
yeah.
Well, I think one of the things to look at with this particular virus is that when we take into consideration its characteristics as far as its virulence is one thing, but also incubation period. From an actual standpoint of maybe, for instance, like a military application, I think its incubation period is a little bit too long. Its mortality rate is a little bit too low, excuse me. And so with that being said, the question then becomes was this the finished product? Like, let's just take the worst case scenario. If they were actually sequencing this particular virus for a weapons application, this obviously is not the finished product.
No.
So that's more problematic.
Yeah, I think that she was in the middle of her work and was not able to finish a lot of the steps because looking at the sequences and looking at the functions that you're mentioning, Supertrez, you're right. It doesn't. It would not have been a good weapon, and the potential for mutation is also problematic because the mortality goes down, but the infection of different organs is very high still. So that's not a weapon that you can use with confidence. There's a lot of error that's involved. I mean, for you, from seeing the patients. For me, I can only predict and assume from the sequence that this is not how you would, this is not your final product. Nobody would publish this. She was in the midst of they were all in the midst of doing the experiments. They weren't done. You're right.
Oh wow.
Yeah. I think for a weapons application, you'll probably have to see like maybe from actual.
You there?
Triz, you there?
Lost your volume, Supertrez.
Infection, complete succumb a patient.
What'd you say?
We didn't hear all that.
A little bit.
Oh, I'm sorry. I'm saying like for a weapons application, you will want the actual complete sequence of events from infection to actual death of patient to be like a week or under.
Okay.
A week or under. So like you want people to, you want enough time to actually transmit the virus, but then to actually be an effective weapon, you actually have to have deaths within a week. Hopefully like maybe 3 days.
I would say,
but let's say you want. Well, if it spread it quickly, wouldn't that also accelerate the response, the identification and the response, and maybe the possible with quarantining of those who were affected. But if you had something that was longer, that had a longer incubation period, then the spread of it would likely be greater and broader. And before you know it, you got millions of people infected.
Well, I mean, in theory, that would sound good, but what you want not only is the actual human casualty, but you want the pandemonium created. So, like if you had something that if people got infected and they died in 3 days, it would create absolute chaos. And so then your quarantine would be ineffective, because how can you quarantine, like basically, you know, the people who are actually performing duties of, you know, law enforcement and military are vastly outnumbered by the general populace.
Yes.
So if there was actual attempt to quarantine people and people just not having it, what could they possibly do? They would be overrun rather quickly. They would have to actually resort to just, you know, summarily executing people attempting to break quarantine. So from that particular perspective,
which wouldn't have been a problem for the Chinese historically.
No.
Yeah.
I mean,
point.
Let's be real.
It is a proximity-based. It seems like more proximity-based virus. So you see it higher. Well, in the beginning, higher cases in you know, certain states, especially like in New York City, saw higher cases. So the proximity, of course, is a factor there for spread and everything and transmission. But when you look like here in LA, a lot of people don't interact with each other. I mean, we drive all the time, all over the place. And so more of the downtown areas, like more close-knit areas where people are walking near each other, that was, and that's a flaw, I would say. If I was looking at this from a design perspective, that would be a flaw, because it took too long to develop its potency as a virus. That if I was only hypothetically looking at this from a design perspective. But yeah, there were a lot of things that I see that I agree with you, Triz. You're saying it's not a complete, you know, system. And my only question is, you know, will it ever be completed? I hope. No, hope not. Hope not. That's all I can say.
I've come to the conclusion there's a lot of people that are going to die. I was just watching the Trump rally, and you got to understand the cognitive dissonance is well beyond what we think it is. They're booing Republicans for trying to give them the proper information.
Okay.
These people do not give a shit. Excuse my language. I'm sorry, I didn't mean that. They do not care. They don't want to wear their mask.
Well, you know,
and it is what it is. And I'm like, okay.
That's what I was about to say.
Look, here's something else nobody's thinking about.
Darwinism.
Some of these people haven't worn a mask after seeing Trump with the mask on. So I'm like, okay. I'm just throwing my hands up like, okay.
Well, also what happened to Herman Cain?
Yeah.
Well, as Bernard Riley says, we're approaching the 3 hour.
Oh Lord!
All right.
So you know, we'll go to the 3 hour-ish mark. But Nicole, I want to ask you a question. In our interview, you said something about viruses, when these types of viruses, when they're designed, they have a time component. I'll say that. So can you talk a little bit more about that? So when these things are designed, they're designed over a course of months, years.
The time component I was talking about is something that's been studied for a long time. I think since like the 50s, 60s. It's called ribo switches, where you can control like when a entity is active, when it's dormant. And so you can just transfer that idea into the viruses, something that is highly active. How can you make it where a person's infected, asymptomatic? Because we're noticing like there are some people who are asymptomatic, but then start to have symptoms. So you have infection and it's developing, but you don't have any symptoms. Some people have the infection, have symptoms the whole time, pretty much, or almost not immediately, but, very quickly. So there's something that I'm looking at as far as like the timing that occurs, and that's due to sequence. It has to be due to sequence. So, and it also can be due to like a chimera type of virus that's developed, and which is why you saw so much sequence homology comparing the two bat sequences to the human sequence from Wuhan and the human sequence from the United States. There was a lot of sequence homology going on, okay, with the virus that the gene sequence of the virus that was detected. And all of that has to do with like, developing those chimeras. They did that. It's like what, 2000, I think it was 2000, 2003 on my slides, where they developed a chimera. They mixed the, the spike protein of a cat with a spike. They replaced the spike protein from a mouse with the one from a cat for the virus. I think it was a hepatitis type of virus. And they used that chimera for that particular study. So that was way back. This was before the Human Genome Project, I believe, and they were doing that. So speaking to like the ribose switches and the way you can, place certain sequences there for timing, all you're really doing is manipulating how the sequence is read, how the sequence is written, and how the sequence is edited. Those are the three main things that you're manipulating. So that's what I was talking about. The timing to develop, like right now, it's 2020, the time that it would take to develop one of these viruses, like, I ain't gonna say, but it don't take a long time.
Okay.
So that's not what I meant by timing, like the timing of developing the virus. I meant the timing that you're programming into the virus of when it's going to do what it was programmed to do.
Yes.
So it just like you can produce a population of carriers, and you have this wave of infections that keep happening. That's what I think, and I'm based on what I'm reading. It's a lot of the articles I can't find them anymore. It's all in my head, and I'm like, oh. So I wrote notes and stuff, but I can't find the articles. They're black. They're gone. So the ones that I can find and I can reference, that's the type of stuff they've been doing. And I can't even say they all the way, because we dibble and dabble in some of the stuff too. But I have limitations. I have ethics. I'm not going to do that kind of stuff.
Mm-hmm. Okay.
The things that men create. Y'all men.
No, she said men.
Y'all men, I'm just gender war again.
For every new technology, there's an upside and a downside. It could be used for something breakthrough, or it could be used it could turn into something monstrous.
Mm-hmm.
And that's how the movie I Am Legend with Will Smith, that's how that movie started. There was a virus that they created to cure cancer, and it turned everybody into zombies.
Yeah. Yeah, I read about that. Yeah. That's what I'm working on. Dr. Gummer, why you have to say that, man? Why'd you have to say that? Man.
That was a good movie, by the way.
It was a good movie. I mean, yeah.
Kind of sad what happened to his dog, though.
Right.
Yeah. Well, that and his family, but yeah.
And his family. And everybody. But it had a happy ending.
Yeah. Yeah. In the end, the black guy sacrificed his life to save the other people.
Yeah. He made it to the end, almost to the end.
Yeah.
Okay.
So, yeah. Thank you all very much for very enlightening discussion.
No problem.
Hey, thank you for giving us the information.
Yeah. I want to thank Nicole for the continued support and coming on the first time and coming back, and this was really cool.
Yeah, I appreciate it. It's great.
So
wish we had discussions like this, not necessarily on this particular topic of COVID, but in general, because you and I do similar content, and people they still, I think they're still hung up on the fact that they're like, oh, I can't believe he thinks this is real, this is natural and real, and I'm like, oh my goodness. So,
I've heard all that. I don't think this is natural or real, okay.
Our topics are very similar, and I really enjoy today having me here. Thank you so much.
But Nicole, what I also noticed is that we're both also interested in just general upliftment of our people as well. Outside of the scientific realm.
That's true.
So, yeah, there's lots of overlap.
Hopefully, y'all see those links in the chat, and you'll be in there reading.
Okay. Well, we got about 13 minutes left. Anyone wants to ask any more questions or just say something, any parting shots or whatever?
Well, I'd like to say something if you don't mind.
Go for it.
First of all, thank you for having me. It was a pleasure having this dialogue, and looking forward to a future discourse. One topic that I think perhaps if you're interested that we could discuss is just the actual state of affairs as far as healthcare in general. When we look at mortality rates within the U.S. compared to other countries, we're not at the top, although we have one of the largest healthcare budgets in the world. So with the amount of money that we're spending for patient care, we should have better outcomes, but sadly we don't. And so I think that's like a bigger issue to think about in context of this COVID era. So maybe that's a conversation that we should have sometime in the future.
Very true.
Agree.
I agree.
To be perfectly honest with you, I think there's more to come. It doesn't matter who gets in office, because from what I'm reading is they're all reading from the same playbook anyway. So he's not the only idiot up there.
Yeah. Well, Super Tris, I just interviewed someone in aerospace, and if anyone knows any young people who have an aptitude for physics or those kinds of things, that's a good interview to watch. Okay. But what surprised me is that we have a lot of money invested in going to Mars, and the International Space Station. And I mean, I'm not saying that's not important, but based upon what you just said about the healthcare system, it seems like some of that money could go to the healthcare system.
Well, I think my argument is that we already have more money invested in our healthcare system than pretty much any other country in the world. And yet we don't have the outcomes to reflect this massive expenditure. So I don't think throwing more money at the problem is the answer. We have to look at the system we have in place and actually revise it or completely revamp it. And as far as like the actual, the space exploration, I did have a lot of interest in space as a youth. One of the things to consider is that, obviously, there's an actual financial component behind that actual investment of capital into space exploration, because in order to access, there's believed to be a limitless resources available in the asteroid belt in a form of minerals and things of that nature. So I think that's the motivating factor as to why you see that amount of money and dedication on space exploration, because they don't want to be behind the curve, because it's like one of those things where it's uncharted territory. So whoever gets there first owns it, basically. So yeah,
you're right.
Yeah, and China is investing a lot of resources in that.
Absolutely.
So,
yeah, like you look at the movie Avatar. That movie was about mining, essentially. Purging some alien
Right,
world of his
from another
resource.
world.
Yeah.
Okay.
You know what? I think I was so young when I watched Avatar. I totally missed that.
Yeah.
That there was mining.
Yeah, it was about mining.
Yeah.
Yeah, that's why they were there. And wasn't that kind of a play on the Native Americans? Going to some
Somewhat, yeah.
Yeah.
over.
Yeah.
Yeah,
Very
the
much.
Avatar's culture, yeah, that's probably somewhat a play on the Native Americans.
It
Yeah.
seemed like a play on Africans because of the mining concept there.
Oh, that's a good point.
The natural resources coming out of the ground, out of the ground,
Yeah, that's a good point.
to the ground, that stuff. But it seemed just like it was like African, in the rainforest. That's how I saw it.
Yeah, the styling of it, blending of African and Native American,
True.
Yeah, maybe that's what it is. Yeah, that's true.
Yeah.
I
had a question for Super Triz. We were talking about the issue of healthcare. If you were to do a pie chart of all of the major influences of the woeful state of health, not necessarily healthcare, but health in the United States, what portion of that pie chart would nutrition include? And how much of an impact does it have on all of the problems that are manifesting with COVID in particular?
See, and this is a very, very touchy subject. I'm sure there's some dietitians, registered dietitian, and nutritionists that would disagree with me on this. But I believe nutrition is a component, obviously. But I think a bigger determinant of comorbidities is actually activity level.
Mm-hmm.
When we look at the dawn of mankind, from a genetic engineering standpoint, we were more nomadic. We were hunter-gatherers. We were a lot more active. And so not only have we been taken out of our natural habitats, for those of us that are African American, even those to a certain extent who are of a Caucasian descent, we're out of our natural environment, and we don't lead the active lifestyles that we once did. Now, obviously, there's medical advancements and things that we know about our bodies that we didn't know back then. But based on our knowledge alone, we should be living not only longer, but have a higher quality of life. But we don't, because a lot of the jobs that we do, we're sitting behind a cubicle. We're not active. We get home and we relax, and we eat these big meals that we don't normally that we wouldn't eat years ago, centuries ago. So there's a lot of things that go into the state of affairs as far as health in the Western Hemisphere. But I think the biggest factor is just we're just not active enough.
Okay.
All right.
I think that could be discussed on the what you were suggesting, Super Triz, state of affairs, healthcare in the U.S. That definitely could be discussed, because when you're talking about like the 30-hour work week and how that could be, a better option, just an idea, and having options for people to, to work out. That's necessary. Like the timing, like getting to work, and I get up so early just to work out. Like people, and other people do, and it's just like you get to work, you're tired, like you're there all these hours.
Yep.
And it's very draining. I'm sitting in traffic, after working out, then sitting in all this traffic, stressed out. I'm like, what did that do?
Oh, you're in LA too? Oh, goodness.
Yeah. So, and then, yeah, you're absolutely right. You have the cortisol levels going up and down, and definitely needs to be.
Well, I work 12-hour shifts, so I get up at 3:00, or actually I get up at 3:30, work out at 3:30, then I'm at work by 7. But when you start talking about like a 30-hour, most of the people in healthcare have the ability to work 36 hours. Most of us work more, obviously, but you can technically work 36 hours and make more than enough money to live off of. But for most Americans, how does that look, working 30 hours a week from a financial standpoint? Number one. Number two.
Yeah, most think 40 hours a week at bare minimum.
Yeah, so you're talking about 30 hours a week, right? So financial constraints, and then also you have to take in consideration how does that look for the economy as far as productivity is concerned? Because I seriously doubt Japan, China are going to allow 30-hour work weeks. I mean, because in Japan, it's uncommon for somebody to work under 60 hours a week. It's uncommon.
Wow.
So
wow.
most a lot of people in Japan, it's not uncommon to have somebody working 70, 80 hours a week. That's not uncommon. This is the reason why they had those little pod hotels where it's like it looks like a little tube that you sleep in, because people spend so much time at work, and that's just that based on that culture. And so if you start having a society where they say, okay, we're going to work 30 hours a week, will they begin to fall behind in STEM fields? The areas that you really have to put forth a lot of research into to constantly evolve those particular fields. That requires time. You can't get around that. And so when you start cutting
maybe we need to bring the Black Brain Trust guys over for that discussion, because they would probably argue that the robots and the AI is supposed to make up the difference. And I'm not being flippant or facetious.
I'm from the Black Brain Trust. What are you talking about?
Well, I mean your programming guys.
Oh, like Mike, we talking about Mike V. Mike V.
Those,
well, I mean, I kind of agree with Mike V on the fact that there's a lot of automation will kind of supplant human labor, but there still needs to be oversight.
I have a lot of questions about that, but maybe it's something.
I do a little software program. I can tell you, it's not going to replace everything, but as computer gets faster and faster, it's going to have an effect. And these quantum computers, if quantum computers ever become mainstream, it'll be interesting to see.
Just briefly, maybe what kind of effect do you foresee?
Well, if you have the right person talking to the programmer with machine learning, which is the main technology that they're trying to throw at us right now, you can make some very effective software. Machine learning, I haven't really, I've dug a little bit into it, but basically, you write the scenarios that the software is gonna go through. So you gotta understand, computers are not smart enough to think like the human brain, so they can't. It's not always going to think for exceptions. You have to program it to think for the exception. Computers right now are not can't compete with the human brain.
So will this be like the next step in computer programming, or?
Yeah, it's still being explored. They don't even have they have some programming language. I got to look up through some more research on it, but they have programming languages out for it, but nothing has been majorly released.
So essentially, when you're talking about machine learning, you're talking about does that equate to a computer writing code for itself?
To an extent, yes.
So my question then becomes is, like, for instance, a lot of what happens, and you can correct me, Nicole Ali, because I did work in a lab when I was younger. It was a botany lab, and they were doing genetic sequencing at that time using like a pipette and like a gel and electrophoresis. That they were doing like the rudimentary. I don't know. I'm sure it's far more advanced than that now. But a lot of what I saw in that lab was tedious and monotonous work. The same thing over and over and over again.
Which is one of the reasons go ahead, I'm sorry.
So I was going to say, so if you have a computer that can actually, do those repetitive tasks and do it a lot quicker than a human can.
Yes.
Well, I think Nicole was getting us that.
I can tell you, very little secret about programmers. One of the reasons we get a lot done is because we put the complex stuff in the method and we don't have to type a few words in it. It runs it for us. It could be 20 pages long. and we have one word type before us, and it'll do it for us.
We haven't transitioned before, but I see what you mean, because at some point, what AV does and what I do is going to meet, it's going to merge at some point, because but it's going to have to change on an administrative level and as far as peer review for publications, because right now you could use machines to do a lot of the experiments that we do. For instance, you're mentioning, Supertriz is mentioning, like in a gel, doing electrophoresis on a gel with or something like that. Okay, like you do that. We don't have computers or machines that do that are affordable. And if you use that machine, nobody would publish you, because you have to like show like you did this yourself, and there needs to be like statistics. So if that gel has to be run with those samples have to be collected more than once. We don't have the equipment that can grow cells in these plates and look at them under the microscope and give them the treatment and then collect them. Like, we don't have that equipment yet. But with machine learning on the level that AB's talking about, then you can develop that machine, that equipment that'll make life easier. Right now, we do the rudimentary work. It's still rudimentary compared to the sequencing that's done. But we have come a long way, because sequencing will take like weeks to do, and now we're at the point, like, I can send it off on a Monday, and then like literally Wednesday, I have all this data, for thousands of genes that I can look at one time, because I've just given them the raw material, which is the cell, which is the RNA, which is the DNA, which is whatever, proteins, whatever they need from me. And they just plug and chug into the machine. And, it's just a bunch of numbers to me, and, really just a bunch of numbers and stuff, but they know what they're doing. And at some point, I won't need that technician. I'll just walk in and put my plate in the machine and go. You know what I mean? So that's like, I understand what you're saying. Like, it's going to merge at some point with the biotech that we're doing.
Yeah, machine learning is basically teaching the computer what you needed to do.
Right.
And it's already been implemented in some areas. Like, how many of y'all have Alexis or I forget Google's name for it, but Alexa, stuff like Alexa, Siri, stuff like that. That's artificial intelligence. It's learning as it goes.
Okay.
Yeah.
All right, everyone. We are
all right.
I see a lot of folks have left. They're probably going to watch the Laker game now.
Oh, goodness.
Oh, wow.
So I think we'll conclude here.
Okay.
All right.
Thank you, everyone, for coming up. Lioness, thank you for coming back. And hopefully this will be the first of many over here. And I look forward to participating with you all over in your spaces as well.
Thank you so much.
All right, thanks for having me up.
Thank you very much, Dr. Dunbar. Nicole, I've been wanting to ask, are you a PhD?
I'm not answering that. I'm just Nicole.
I want to properly acknowledge, because I keep referring to Dr. Dunbar, and I felt.
No, Nicole is fine. I just do what I can. That's all I can say.
So like I did interview Nicole the first time. I did ask her how she wanted to be introduced, and
okay.
Yeah.
The modesty, okay. No, thank you all very much for your time and great information. Feel a little bit better about what I do and don't know about what's going on. So
it's continuing to unfold.
Yeah.
And as Supertriz said, there's so much we don't know. So it's just unfolding as we go.
Yeah. Thank you, Supertriz, as well.
Thank you.
Yeah. Right. Notes when you were talking. Thank you.
Well, thank you for everybody for having patience with me. I know I get long-winded sometimes. Sometimes you just got to cut me off,
No.
We need to hear from individuals who are in the hospitals as well.
Yeah, the boots on the ground, so to speak.
Yes.
Yeah.
Also, before you guys depart, I want to thank you, especially you, Dr. Dunbar. I missed last week, so I'm kind of glad I caught you this week. Nicole, thank you for your continued work in the field. I'm also subscribed to you and the Black Brain Trust. Dr. Anwar, I hope I see you Monday night. I might burn the building down, so I might need some fire extinguishers there, man. So you guys all take care. Stay well.
All right. Hey, if any of you all are on Facebook, Herb has a show with David Glover, who I interviewed over on my original channel. So they're on Monday nights over on Facebook, addressing some pretty topics.
All right.
Okay.
Later.
Bye, everybody.
All right. Y'all have a good night.
Yeah.
Y'all have a good night.
Go Nuggets.